Good morning. My name is Dean Brenner. I'm the chairman of the FCC's Technological Advisory Council, and it's my pleasure to welcome all of you to our second meeting in 2022. For those of you watching this meeting who may not be familiar with the Technological Advisory Council, or the TAC for short as we call it, we are a diverse group of technology experts who've been selected to provide technical expertise to the FCC to identify important areas of innovation and developed informed technology policies supporting United States competitiveness in the global economy. Let me begin by thanking FCC Chairwoman Jessica Rosenworcel for joining us today. We're going to hear from her shortly. All of us, but especially myself, are grateful to Chairwoman Rosenworcel for appointing us to the TAC and for her strong leadership of the FCC. Today, as the nation and the world continue to battle this pandemic, and as everyone in all 50 states and indeed all over the world, whether one lives in an urban, suburban, or rural area, depends on broadband, largely wireless broadband, in ways that were unthinkable just a year or two ago. So as a result, our work on the TAC is especially important now. As many of you will recall, in announcing our appointment, Chairwoman Rosenworcel wrote, and I quote, "The United States must lead the world in advancing ambitious 6G research and development. We know that maintaining our leadership in high priority emerging technologies requires careful planning and execution. There are signals that need our attention, from the need for more spectrum to the vulnerabilities of supply chains to the changing dynamics of global standards development. We are starting that work here and now by reestablishing the TAC and charging it to conceptualize 6G to help set the stage for our leadership." I could not agree more with Chairwoman Rosenworcel's vision, and we've been hard at work to flesh it out, seeking input far and wide. Establishing U.S. leadership in 6G and other emerging technologies, all of which are important, building on our leadership in prior generations of technology is so important for the United States economy, the global economy, and our standing in the world. Over the past few months, I've been asked several times if it was too early to begin planning for 6G. I even heard an industry player of some sort express that view. I disagree strongly. It's true that 5G is in an early stage. 5G will continue to evolve and improve. Terrestrial 5G and non-terrestrial 5G, along with so many other technologies such as Wi-Fi, cable, and broadcast, and others, all have a bright future ahead. That's all great, but as a country, we cannot rest on our laurels. The world is not waiting for us to wake up and begin working on 6G and other emerging technologies. No, every day we see numerous efforts all over the world on 6G moving forward. In North America, the private sector has begun working on 6G, but they can't do it alone. So without a doubt, Chairwoman Rosenworcel did not jump the gun by charging us, the FCC's technical advisors, to gather and provide valuable input on the myriad of issues surrounding 6G. The FCC needs our best input now while 6G is on the whiteboard, not later when it's going to be too late. Indeed, one lesson that I think we've all learned from prior generations of wireless is that getting all the relevant players to the table up front to explore and collaborate on issues is so much better for everyone, including especially the public, instead of having to scramble around after the fact. And that's precisely what the TAC is doing on 6G. So let me extend my profound thanks to Chairwoman Rosenworcel for appointing me to lead this group and for appointing all of you, my colleagues, to the TAC at this crucial time and giving us this visionary task. You will hear throughout the meeting from the leaders of our 4 working groups. Those groups are 6G, advanced spectrum sharing, emerging technologies, and artificial intelligence and machine learning. There's a good deal of overlap in the work of our 4 groups, and that's fine because fortunately, we are closely coordinating with one another. Some of our work is on exciting new technologies under development, extending way beyond 6G too, and that work is equally significant. I'd like to thank by concluding my fellow TAC members and offer a special thanks to those of you who are leading a working group. We're all busy, and I really appreciate the time that all of you are devoting to the TAC's work. Now I'd like to turn the floor over to FCC Chairwoman Jessica Rosenworcel.
Thank you, Dean, for that glowing introduction. Listen, more importantly, thank you for your leadership of this committee. I've been around the FCC long enough to know that if you want to have an effective advisory group, you're going to need an effective leader. And everything I've seen from you over the past several months has really affirmed that we made the right decision asking you to lead this iteration of the FCC's Technological Advisory Council. Now, I also want to echo Dean's words, thanking all of you for serving as members of the TAC. You know, the really big challenge with assembling a team of experts for an advisory committee is that the best people have a lot of other commitments. And so we don't take your time and talents for granted. You're all in high demand. And I'm really grateful you have chosen to volunteer and serve on the TAC. And special thanks to those of you who are working as working group leaders. Now, on a personal note, I also want to thank the members of the FCC staff who do a lot of work to support the TAC. In particular, I want to recognize Michael Ha and other members of our Office of Engineering and Technology. Now, as you know, this is the second meeting of the TAC since we announced a new lineup of members last year, and I regret I wasn't able to join you for that first meeting in February, but I just want to say I get a hall pass for this one. I got a very good excuse because while you were meeting on February 28th, I was in Barcelona getting ready to address the biggest annual gathering of public and private sector leaders on mobile communications. So what did I say before this audience of global VIPs? Basically, I made the case for why this version of the FCC TAC is so important. In other words, I couldn't make your last meeting because I was at Mobile World Congress helping set the stage and describing your most important work. I know that probably feels like a bit of an exaggeration, but I'm going to invite everyone here to go ahead and look at my remarks. I put them on the FCC website because I use this high-profile platform to say, now's the time to start talking and planning for 6G. And I wanted to talk about why we have to start thinking seriously about this next generation of wireless networks. And I punctuated this argument by saying, what the FCC has done is we have set up a group of experts to figure out where to go next, and that's our Technological Advisory Council. I said that this effort is going to help us turn the latest scientific research into the communication technologies of the future and set the stage for US leadership for 6G. So no pressure, none at all. Now, people have taken notice. It was just 2 weeks ago, 2 weeks after those remarks, that the Wall Street Journal ran a story with a headline, "Forget 5G, let's talk about 6G." And it was a good article. And I'm not just saying that because it prominently featured Dean Brenner and fellow TAC member Ranveer Chandra of Microsoft. So thank you both for speaking up. And as Dean noted in his opening remarks, when it comes to the US government efforts on 6G, the TAC is only the tip of the spear. You are the only government affiliated group specifically focused on 6G. It's why your work is so important. And again, we're putting a lot of pressure on a team of volunteers, but I have every confidence that you are up for the challenge. I say that first and foremost because when I took a look at the TAC's membership, one thing became clear to me: you are a team of all-stars. You're some of the most respected leaders across the tech and telecom sector. I also believe you're going to do a great job because the TAC history, well, you've inherited quite a legacy. It's played a key role in so many of the Commission's most important actions regarding mobile innovation. I mean, since the early days of the 5G rollout, I've touted the need for an increased emphasis on freeing up mid-band spectrum and exploring innovative spectrum management policies. And guess what? It was the TAC that did a lot of the critical early technical work on both of those subjects to help us create a framework for dynamic spectrum sharing. And that has been a big success in mid-band spectrum, namely the 3.5 gigahertz band. We are absolutely looking forward to more insights from this group on the key questions and getting more use out of our scarce spectrum resources through creative ideas about sharing and other things that you come up with. Now, another longstanding priority for me has been promoting the possibilities of open radio access networks to make our communications supply chains more diverse and resilient. And last year, we launched the nation's first ever open inquiry into Open RAN. And of course, who was on this issue first? It was the TAC. And so I look forward to you continuing to driving the thinking forward on the virtualization of our networks and the role Open RAN can play in 6G. And that's not all. Future networks are going to rely on more automation and technologies like artificial intelligence and machine learning to achieve greater efficiencies. And we always need to keep a focus on identifying how emerging technologies can be leveraged to solve our most important communications needs. So those are big issues. Again, no pressure. And I when I think about how important the work of the TACT is, something comes back to me, which was a line from a commercial when I was a kid. There were these commercials for E.F. Hutton, and maybe some of you are old enough to remember this. This was the 1980s, and the tagline was, "When E.F. Hutton talks, people listen." And I think what I just demonstrated is there's a long history of showing that when the TAC talks, the FCC's leadership listens. And I want to assure you that when it comes to your recommendations on insights on 6G, I'm going to be listening closely. I'll make sure my colleagues are listening closely. And by the way, that's also true for the work you'll be doing on spectrum sharing, AI, machine learning, and other emerging technologies. All right, so I've rambled on, and I think it's time to start talking and let you get over to the work before you. I just want to thank you again for your service and for helping the FCC think about the future and make sure that our policies are bold and bright. And with that, I'm going to turn it over to Ron Rapazzi, who's the acting chair of the FCC's Office of Engineering and Technology.
Thank you, Chairwoman, and good morning, everyone. I will try to keep my remarks short as well so we can get into the meat of the presentations. I've had the opportunity to dive in to the material. We've come a long way. You working group chairs and the working group participants have come a long way since our February meeting. You've had regular weekly meetings over the course of the last 3+ months. The approaches that you're taking to delivering on the topics that were assigned to the various working groups are formulating in a way that I think is in a positive direction. One of the areas that I was concerned about was the overlap, but I've come to the conclusion after looking at the material for this meeting that it's not much of an overlap as much as it is a synergistic interrelationship, interdependence among all the different working groups. And as the Chairwoman just mentioned, the area of spectrum and spectrum sharing, spectrum allocations, as well as the supply chain and the security, and how things like artificial intelligence and other emerging technologies factor into 6G network formulation and deployments, as well as some of the other emerging tech issues that would support 6G operations, to include things like smart antennas, adaptive array antennas, and things like that. So, and they all blend together, and they all support each other in the name of deploying a 6G, a healthy and secure 6G vibrant network. So we're at the very early stages, of course. I will admit that. But again, I'm pleased to see that the working groups have worked through those potential overlaps, and they've kind of gotten to a point where they're focusing in on working group specific topics that again are synergistic and not overlapping and wasting time and effort building upon some of those topics. So with that, I want to extend my thanks to all the people who participated in those working groups and the working group leaders who got us to this point in the mid of the cycle. The end of the calendar year for the actionable recommendations is not that far away, but I'm pleased to see that things are where they are. It looks like we're on a really good and positive path to meeting the expectations for the end of the calendar year. So thank you to everyone. And Dean, I will turn it. I think Michael's going to have some remarks. I'll turn it to Michael, and then we'll carry on with the business and stay on schedule. Thank you.
Yeah, thank you, Ron. And so as pointed out by the Chairwoman, Dean, and Ron, we cannot thank you enough for your commitment to serve the Commission and all the discussions and participation from all the representatives here, as well as the working group members. This year has been extraordinary, given how the meeting has been participated virtually for all of us, and I think there's a lot of additional achievements we're getting. I think there's a lot of efficiencies that we've been achieving as well. As Ron mentioned, we're about halfway through. We're kind of a turning point of the long marathon, the year cycle. So we hope to go through the presentation today, and for the remainder of the TAC meeting for this year, hopefully we'll start narrowing down to some of the key topics and start thinking about the actionable recommendations for the Commission. Let me turn it over to Martin for his quick remarks, and we will get on with the program, and cannot wait to see the presentations. Martin?
Yeah, it's hard to follow that. So I'll just keep it short and say also thanks to everyone for your hard work. It's clear there's a lot that went into these slides, and I'm looking forward to the presentations. Thank you.
Great, thanks, Martin. We're not going to do individual roll call.
Over to me now.
Okay, maybe there was a bit of a lag. So we will take the attendance from there's a meeting participant list. I don't think we have anyone on the conference bridge, so we have all the names. We will take that. And also would like to introduce a new member. Doug, Greg, are you on?
Yeah, hi, Michael. How are you?
Yeah, so Doug is joining us from NTIA. So he is representing NTIA, and he will be a full member of the TAC. And he has not been joined any of the working group meetings. So after this meeting, he will be reaching out to, or I'll reach out to some of the working group chairs to get him involved, so that we will have some a very good feedback from the NTIA representative for the federal government side, so that some of the input can be fed into some of the formulations of the tax final recommendations. So with that, let me turn it back to Martin, who's going to be driving the presentations. Martin, should we start with the...
Is it sharing? Do you all see it there?
Yes.
We see
Yeah, it's
it.
coming through.
Okay, great. So yeah, but gone through most of the opening remarks. I think we're moving ahead to the reduction of roll call. So I guess we're on to the 60 working group. If anybody would like to take over.
Yeah, hi, this is Brian Daly. I'll start. Well, thank you for the opportunity to present the 6G working group status on behalf of Mano Gosain from the Institute of Wireless and Internet of Things at Northeastern University, and myself, Brian Daly of AT&T. First off, I'd like to recognize and thank the FCC liaisons listed on this slide for their participation and guidance in our working group. Next slide, please. We couldn't do this work without a good team of experts, and I won't go through all the names obviously on this list, but we do have a very diverse group of industry leaders who are contributing to the work looking at 6G. And as the chairwoman mentioned, no pressure on us or anything defining the next generation. But it is a task that is very important to maintain leadership and U.S. leadership as we develop the next generation technology. And I just want to take this opportunity to recognize and thank all the working group team members. Next slide, please. So just a review of our working group charter. We are looking at the development and deployment of 6G technology to provide information on insights of new developments that need attention, including the need for more spectrum, as well as vulnerabilities in the supply chain and the changing dynamics of global standards development. As mentioned earlier from the chairwoman, Open RAN and Virtual RAN, how will that continue to evolve and benefit 6G technology development in the ecosystem? And are there adequate levels of security provided in Open RAN and Virtual RAN architecture? And what are the cost-benefit trade-offs to consider? We also are looking at the opportunities for using millimeter wave and terahertz band for fronthaul and backhaul to support what's anticipated to be the dense deployment of 6G systems, given capacity capabilities and corresponding bandwidth demands that are anticipated as we evolve to 6G. We are also looking at how applications for 6G will enhance or utilize
autonomous driving, edge computing, emergency alerting, and smart city technology deployments. And finally, how can we use 6G technology to help bridge the digital divide by bringing down the costs of delivering broadband, particularly to rural and urban and underserved areas? Next slide, please. 6G encompasses quite a broad area. And when we look at what the other working groups are doing, we do have obviously some overlap with some of those working groups. And let's see, I'm not sure if the slides have changed. I don't see them on my end yet. There we
Sorry, I
go.
must be experiencing this.
Yeah, I've got it now. Obviously, as we look towards 6G, intelligence and intelligent capabilities within the network are going to improve the utilization and administration of spectrum. And this, we are going to work closely with the AI/ML working group. And applications that are anticipated to evolve with 6G will also look at emerging edge AI techniques, as well as methods and techniques to assist the safety, security, and performance of network equipment, network control, and network operations that are going to increasingly rely on automation. All of these have close ties to the AI/ML working group, and we're going to work closely to develop actionable recommendations along the lines of intelligence and automation that work closely with the AI/ML working group. And of course, emerging technologies. 6G in itself is an emerging technology, so we'll be working with the Emerging Technologies Working Group on insights into new developments in the IoT ecosystem, as well as spectrum access and the need for potential high bandwidth devices, as well as small satellite development, and what frequency bands are under consideration for the use and what services are envisioned. And finally, as already mentioned, spectrum, of course, is one of the key areas that will be addressed as we move to 6G, especially services above 95 gigahertz, and we'll be working closely with the Advanced Spectrum Sharing Working Group. The general approach we've been following, we all know we have to get to actionable recommendations by the end of the year. We're using subject matter experts that we're bringing in for presentations and also doing research of the reading material. We're using the subgroups defined of working group members and facilitators to break off into subgroups to address specific topical areas. And we have weekly meetings with working member participation to discuss and deliberate on the various topics of our charter. We are working towards those actionable recommendations, but since this is 6G, there will be items that will require a future study beyond this year's TAC. Now, 6G is an industry term, but it's not yet defined. There's various stakeholders defining a vision for the requirements, spectrum, component technologies, architecture, and applications that will eventually coalesce toward a shared understanding of what 6G will be. Multiple charter questions require continued attention and further study, as I mentioned. Next slide. So topic number one, the key takeaways in the development and deployment of 6G. We are trying to understand what is 6G and get an understanding of what that ecosystem might be. What are the lessons we've learned from 5G deployments and how will that shape 6G development? What's the timeline for 6G? What candidate radio access network, compute, chipset technologies, and so forth will drive 6G development? What research is underway, both in the US and globally? And what's the role of the ADAS NextG Alliance and federal funding agencies in North America? And how does the US prepare a competitive workforce to develop and deploy 6G? What's the anticipated 6G standardization plan, including what standards groups will be involved? What dynamics come into play for standards development? How US standards representation bodies coalesce to help maintain US standards leadership? And is there a risk of fragmentation of standards due to the global pandemic and geopolitics? And what are the spectrum considerations and timeline for 6G? How do we get a head start on early potential regulatory barriers that could slow 6G deployments? And are there issues that could come up in coexistence between 6G and adjacent services regulated in part by agencies other than the FCC, which we should highlight now? And what are likely issues about siting for 6G, which implicates state and local regulations too? And finally, what are the supply chain considerations and vulnerabilities? So looking at an initial view of defining 6G, 6G itself is an industry terminology. If we look at the ITU, it's not a term you're going to find within the ITU. The ITU defines a process in their Resolution 65, which defines the development of an International Mobile Telecommunications Release, or IMT. The ITU Working Party 5D is currently developing the vision for the next generation of IMT beyond IMT 2020, and they're referring to this as IMT 2030 and beyond. And they'll additionally define a set of requirements for the terrestrial component of IMT 2030 following that vision. In addition, ITUR Working Party 4B, they're currently defining a vision and set of requirements for the satellite component of IMT, and they're currently working on the satellite component for IMT 2020. Multiple stakeholders do contribute to define the 6G vision. We have terrestrial mobile networks, non-terrestrial networks, including high-altitude platforms and high-altitude IMT base stations, or HIBs. We have satellites, we have hyperscalers, we have device manufacturers, and application verticals, just to name some. It's anticipated that multiple regional, national, and global telecommunication fora are going to shape the IMT 2030 vision in the coming years. And an emerging view is the next IMT will encompass a heterogeneous architecture enabled by licensed, unlicensed, and shared spectrum across low, medium, and high frequency bands. The question is, which fora will develop candidate radio technologies to participate in the ITU's evaluation process for the next IMT? And what are the implementation recommendations for IMT 2030? How do we avoid fragmentation? Next slide, please. So taking initial view, what is the next IMT or 6G? The IMT divide, I'm sorry? The ITU defines a new vision for IMT approximately every 10 years. For example, 5G was the IMT 2020 in the ITU. So it's anticipated that 6G will be IMT 2030. 3GPP, for example, develops the specifications which are submitted as a candidate technology into the ITUR and labels or brands releases as indicated shown on the diagram. So for example, in the IMT 2012, which was 4G, we had LTE, LTE Advanced, and LTE Advanced Pro. Those were the 4G technologies. The 5G technologies, we have 5G as 3GPP release 15, 16, and 17, and 5G Advanced will be release 18 and beyond. And then, as mentioned, it's anticipated releases 21, 22 will be IMT 2030 or 6G. 3GPP has not defined a branding nomenclature yet for 6G, which is why you just see a box there with no brand marking. The ITUR Working Party 5D is currently developing a new draft recommendation, as mentioned, for the vision of 2030 and beyond, and this will be completed in 2023. And as mentioned, Working Party 4B is developing a draft report on the satellite vision and requirements for IMT 2020, and this will be completed this year. Working Party 5D is also studying future technology enablers for IMT 2030 as a new draft report, as well as future spectrum capabilities such as those above 100 gigahertz. And studies are also underway regarding future spectrum for IMT in conjunction with various World Radio Conference 23 agenda items, such as identification of various frequency bands for IMT, along with other IMT-related agenda items. Next slide, please.
Okay. Thanks, Brian. Thanks again for the introduction, and I just want to echo my acknowledgement both to the FCC liaisons as well as to the TAC chair team. So continuing on this theme of the topic one, which is around development of 6G, just before getting on to this slide, just wanted to add and echoes work that Brian has just very nicely laid out in terms of a timeline. We do see at this point two separate paths emerging. One, which is what we have defined here, which is what, for lack of a better term, you could call an evolutionary path, which will sort of follow along what has happened in previous Gs. However, what we are also monitoring, given the various stakeholders that you saw in a previous slide, the revolutionary path. And that is something that will require further study. And we are continuing to invite further subject matter experts to see which direction or which of those key stakeholders may move the needle into 6G along the revolutionary path side. So that's sort of the overarching takeaway for us at this time, early on in this particular topic area. Moving on to the 6G spectrum needs. So our goal here is to generate recommendations to the Commission on next-gen technology development, especially outside of the purview of current proceedings and NPRMs that we have listed here. So we're taking a vertical outlook all the way, the full stack, from devices to subsystems to holistic architectures, and the clear front-running deduction that we collectively have is that we are going to require low band, mid band, and high band beyond the millimeter wave frequencies that are part of 5G today. So the notional bands that are under consideration, and also want to make sure that there is strong overlap with the spectrum sharing group. So we will not go into details here. We will hear that from Andy and Manisha a little bit later. But we do want to sort of emphasize the last 4 bullet points, which is looking at 100 gigahertz, 100 to 300, 300 to 1 terahertz, all the way up to 3 terahertz. Also, we'll be looking at novel ways of using existing frequencies as part of the overall 6G architecture, and also consideration of how do we use unlicensed bands that may be designated for mobile communications as 6G is defined. So next slide, please. That wrapped up the first topic area we had. Again, also want to acknowledge the breadth of the charter that we've been given, and now I'm switching over to the component technologies that were part of the charter that came to us. So the topic area now, we'll be talking about Open RAN, O-RAN, vRAN, and some of the main key questions that we are studying and we'll be reporting on are around how does Open RAN continue to benefit 6G technology development? What is the current state of affairs in the Open RAN ecosystem? Will it be a fundamental part of 6G solutions, or what other innovative architectural approaches are being seen that will help define 6G? How is Open RAN going to be standardized given the breadth of standard development organizations, and what are the connections between them? And then the last point connects back to the AI/ML working group, which is how does AI/ML algorithm design factor into ensuring that Open RAN is part of 6G. So next slide. Our key takeaways, first of all, tell us that 3GPP, which is the existing standard development organization, and Open RAN are more similar than different. On the left side is where the entire network architecture, all the way from the signaling mechanism on the radio access network side to control messages, user plane messages, interface definitions are defined. The O-RAN Alliance, which is sort of the at the front of the pack in terms of defining or coalescing a collective vision around how Open RAN would be deployed, is actually focusing on a subset of what's happening in 3GPP, primarily on the RAN optimization, as well as on inline hardware acceleration and applying AI/ML techniques to optimize the RAN. So the O-RAN Alliance is consistent and extends the 3GPP architecture and interfaces, and will very clearly maintain alignment with future 3GPP releases. Since the TAC has been formed in the last 3 to 6 months, we have observed that there are clear existing liaisons between the ORAN Alliance and 3GPP as well as ETSI, and the ORAN specifications have started to be submitted to ETSI under the publicly available specification process. So now this sort of shows a very strong alignment and lockstep between the different alliance specifications as well as what's happening in the standard development organization. So helps alleviate some of the concerns around fragmentation, etc. So this is collectively the industry as well as SDOs as well as regional and national bodies have sort of come together, and hopefully this is going to evolve, but this is going to be something that our TAC is going to continue to monitor. Next slide, please. On the security side, we were given a question around looking at the security footprint, given that there are multiple new interfaces and there are increased attack surfaces. So how will ORAN implementations be secure or more secure? What's the security risk assessment? How do we see the Open RAN architecture security requirements complement what's being developed in 3GPP, and then identifying the new attack surfaces introduced by these new logical components, and then how are we addressing these vulnerabilities, and then how does data protection happen given the context of AI/ML modeling and training. So the key takeaways for us on the next slide are there is an entire community in the ORAN Alliance called the Security Focus Group, which is comprised of security experts all across industry as well as academia, and they have sort of collectively identified some of the security risks. On the right is the ORAN notional architecture, the key components that we've heard from the subject matter experts and will be monitoring and be passing the information back to the FCC are key across service management and orchestration, which is at the highest layer, which is essentially going to look at how do you control or orchestrate the applications that are going to be, and all the different components that need to be connected for making an end-to-end Open RAN compliant architecture and delivering the quality of service or quality of experience that will be required. So the security vulnerability can be exploited to serve as the main entry and exit point for attacks, and also move the attacks on a lateral horizontal fashion. The other one is around applications, RApps or XApps, which is a concept introduced in the ORAN Alliance, which allows third-party application developers to deploy application services that then need to be translated into their infrastructure requirements. And there is a lot of strong use of AI and ML. The good news here is that this is there are the same security issues that the AI ML computer science community is dealing with in terms of data protection, explainable AI, curation of or building models, and it's a recognized challenge across not just our industry, but other industries, and we need to sort of come together and work on exchanging best practices. Open front haul, which is sort of the key innovation, which allows to disaggregate the radio access network into different physical elements. The lack of encryption and authentication can be used to inject attacks, and the lack of sort of protection on the control plane can be exploited to cause basically an outage or interference that needs to be protected against. The OCloud, which is the Open RAN cloud that essentially helps orchestrate all of the different physical elements that could be deployed in a cloud native fashion. So there are interfaces like the O2 interface, and for that we share the common cloud security risks with the broader hyperscaler community and have contributions there. Next slide. So it's not all doom and gloom. The risks have been identified, but so have the mitigations. So the ORAN Alliance is pursuing a zero trust architecture in accordance with the NIST standard 800-207. And there are active work items that have been shared to primarily secure the radio intelligent controller, both the non-real time as well as the near real time, as well as some of the risks that were identified on the previous slide. The goal is to ensure that the interfaces are secured according to the best practices such as TLS, IPsec, MACsec, as well as certificates for authentication purposes. And then the idea is in cloud native deployments to implement cloud security best practices. Next slide, please. Moving on to the next topic, which is around next generation technology development. This topic is looking at the higher frequency bands beyond just millimeter wave and different novel architectures that have been defined in 3GPP, but are yet to be deployed on a commercial scale. So how do we see the millimeter wave and terahertz bands? And how can we be, first of all, from a spectrum sharing perspective with radio astronomy and incumbent Earth exploration satellites, how do these bands support technologies for backhaul purposes or for sidelink or device-to-device communication? And what are the material innovations that will be required to influence the development of cost-effective radios, keeping in mind all the different factors of swap, as well as power consumption and energy efficiency, which will be key, which is a key topic that we have seen is being considered for 6G from day zero. Next slide. So the opportunities first, right? So why do we even go up to these bands? So it has the key joint communications and sensing at these frequencies, given the frequency characteristics that are available and the kind of impulse waveforms that are generated allow you to sense on the same channel that you're communicating on, which opens up wireless communications to a whole new set of technologies, which can influence not just bridging the digital divide, given the high capacity backhaul links that can be created with these networks, but can also help from a sensing perspective to influence climate studies, or given the nanoscale devices that we can build, you're looking at also transforming healthcare as well as indoor localization and positioning. So the opportunities exist, hence the TAC is looking at it, and a body of researchers is continuing to work on this. Next slide. But it doesn't come without the challenges that are required to realize the true terahertz vision. So we have monitored and we've heard from subject matter experts primarily around the challenges of devices. There are a large variety of materials that have been investigated, from silicon germanium to silicon on insulator, which is the manner in which some of these devices can be used to build the radios. But there are some performance plateaus. There are other materials such as indium phosphate as well as gallium nitride, so GaN and INP, which have better performance, but we require the process of layering these chips on to build large massive arrays, because you are now constrained at these higher frequencies to shorter wavelengths, which require high power massive MIMO arrays to reach the true potential and distance coverage required to reach economy deploying true terahertz technologies. We're also looking at the realization of D-band phased arrays, so somewhere in the 120 to 170 gigahertz, and the evolution of 5G array technology. So this is again a key area where we need to continue to monitor, where industry as well as the device research centers across the US are evaluating the different materials that are going to be used to develop terahertz. So there are propagation and challenges to realize the terahertz vision. We get huge transmission bandwidth, but as I said, at a cost of very high path loss. So if you, sorry, there may be some effects on this slide. So if you keep pressing, we'll see more material pop up. So there is molecular absorption. So if you keep going, maybe 3 or 4 more clicks, you can just 2 more clicks. Thank you. So there's absorption, there's spreading losses, there's blockage, and what you see is this, on the bottom, you're seeing the frequency and the loss and the spreading that happens. But there are different kinds of techniques and approaches, solutions that are being investigated right now in academia as well as industry to define the right waveform, to really use dynamic directional gain and to use intelligent reflecting surfaces to counteract the absorption losses and blockage issues that right now make realizing the terahertz vision at a commercial scale not a reality. Next slide, please. So this is moving on to the application verticals across autonomous driving, edge computing, emergency alerting, and smart city technologies. So the kinds of questions we are approaching is what we've heard so far in topic 2, 3, and 4 were the component fundamental technologies, novel network architectures, the use of AI ML. But what good does it do, and how does that interface with the kinds of KPIs that will be put on for 6G? So what has not been delivered or was promised but not delivered in 5G, and how does that get coalesced together into defining what are the use cases that are going to drive 6G, and what are the key enablers that we saw on topic 2, 3, and 4? How can 6G address, for example, safety for autonomous driving? So level 5, fully autonomous driving. What are the challenges from a security and regulatory perspective, especially as we start talking about data, AI, ML, and privacy of citizens, as well as how do we use 6G to enable smarter cities, as well as have an impact or on socioeconomic growth in cities. So will 6G have a role to play there? Next slide. So we factored this into two main questions, and the guiding principles that we're looking at is the application that we come up with, or industry comes up with, cannot be delivered with 5G or 5G advanced because of the feature functionality requirements being unique, or the performance reliability requirements are too high to be met today. And then the applications can be delivered maybe through 5G and 5G advanced, but their efficiency could be improved, either capacity, cost, performance, latency, or reliability. So keeping those guiding principles, this is just a canonical, non-exhaustive list of some of the use cases on the next slide that we believe will drive 6G to define the KPIs. So immersive experiences, holography for training, education, healthcare, or travel, multi-sensory communication, tactile internet or haptic control, high resolution mapping and digital twinning. And this is really, really important because now there's a lot of demand for data and a lot of computational demand, as well as for cobot. And this is robot to robot interactions. And I would highly encourage folks to go and check out experiments done by Nokia Bell Labs, where two robots met in an elevator, and how that interaction for those two robots went. And that's quite a fascinating watch. But at a technology level, you're required to look at precision, positioning, and sensing. For level 5 autonomous driving, the ability to see around the corner. And then how do you make highly secure communications to mitigate eavesdropping, either through directional beamforming or other techniques. Some of the common characteristics that will define, again, some are common, which is around throughput latency, but then we also see things around the number of streams, given the large number of antennas. So what are the number of streams that each base station will be required to serve, and how many users will be served? We're talking about sensing and joint communication and sensing. So there's a sensing accuracy that needs to be really high to meet public safety applications, positioning. And these are some numbers that are very, very aggressive, but this is what we are seeing from some of the analytical studies that have been observed and the group has studied and reported back on. Next slide, please. Over to you, Brian.
Okay, thank you, Manu. So topic 6 is helping bridge the digital divide, and will 6G be the first mobile radio generation truly aimed at closing the digital divide? And with that, we need to understand what the challenges are between rural and remote areas, and what requirements need to be included in 6G in order to meet these challenges. And of course, the pandemic has given us a lot of lessons as more and more remote users needed broadband access. What were the lessons we learned from the pandemic? And what architectural approaches combining non-terrestrial and terrestrial connectivity could help provide robust and wideband service in rural areas? And how will 6G address spectrum and backhaul for rural areas? And what technologies can address cost performance coverage to bridge the digital divide? And finally, can 6G provide an affordable, sufficient service compared to solutions for urban, suburban population areas? So one of the ways to try to gain information on this is we brought in some subject matter experts that are looking at the digital divide problem and the impacts of the pandemic in the state of Arizona. And we had some representatives of the Arizona Telecommunications and Information Council, specifically what they call their COVID-19 Digital Access Task Force, come in and talk to us about their report and recommendations that they've made within their state. Now, Arizona is a good use case because you've got urban, you've got suburban, you've got rural, and you've got tribal areas all need consideration for broadband access. And the pandemic impacted all areas across the state. What the lessons learned, obviously, is nothing new. There was an unprecedented demand for digital access. And what is digital access? It's more than just internet access. It's access to computers, smartphones, home hotspots, skills and technical support to use the devices, internet, and applications, digital and web literacy, as well as access to digital content, applications, and other resources. So what they're looking at and the lessons from the pandemic are affordable internet, digital inclusion, as well as digital equity. And there was a focus on education. How do we close that homework gap for students when you're doing remote learning? Telemedicine, again, when you're in rural areas or don't have the ability to go into a medical office due to the pandemic, how do you support the medical needs of the state? Public safety, obviously, is a big one. And one other area that they focused on was libraries. How do we get information that typically the citizens would go to libraries to gain access to? How do we get that information out if the libraries are closed down or you can't get access to the libraries? The challenges that they highlighted, they really demonstrated the need for public-private partnerships to address middle mile and last mile infrastructure, as well as looking at the barriers to resolving broadband deployment, such as return on investments, access to right-of-way funding. They are looking at innovative solutions to meet the challenge, including smart highway corridors, where they would use the interstate highway corridors to deploy fiber optic runs. They're looking at device refurbishment and donation programs so they can get devices out to more citizens. Looking at device as a service, as they call it. Again, the whole intent is to be able to get devices to more of the citizens. Broadband and digital access community teams, where they bring the local communities involved in looking at their broadband and digital access needs, as well as bringing in non-traditional providers such as electric cooperatives for providing digital access. And of course, funding is the big issue. How do we get funding to pay for all of these initiatives? Next slide, please. So just as an acknowledgement, as mentioned earlier, we did have a number of subject matter experts that came and presented to us. We would like to acknowledge and thank the subject matter experts listed here who gave us excellent presentations and brought valuable information into the work group. Next slide, please. So our next steps, obviously, we're going to continue collecting information on the assigned topics, but we need to start formulating those actionable recommendations based on the presentations and working member inputs. Those actionable recommendations, again, will come in our report at the end of the year. But again, since 6G is a multi-year effort, there will be some future study items that we will recommend as all. So with that, I'd like to, on behalf of Manu and myself, I'd like to thank you for giving us the time to present our working group status. And at this point, I'll turn it back to Dean.
Great job, Manu and Brian. Do folks have questions or comments? Well, let me start then. Fantastic presentation, guys. One thing on the the first topic and the timeline. So, and I know I've said this before, and to me, it's a very key point for folks who are maybe not familiar with the way things played out in prior Gs. So while it's, you gave a great snapshot of the ITU effort, the IMT 2030 effort. Of course, if something's going to launch in the 2030-ish timeframe, 2029, 2030, even 2031, that means that there are a lot of efforts that are happening in parallel. So the 3GPP efforts won't wait, obviously, until the 3GPP effort of figuring out post-release 18, so the initial 6G releases, whether it's going to be 19, 20, 21, whatever, that has to happen kind of in parallel with the ITU work. And of course, the spectrum allocations also nationally, regionally, globally, that work can't just be on hold until 2030. That work has to be starting up in the, planning for it now, and then proceeding into the 2020, 2025 and beyond. And I think that's what we're seeing play out. So let me just stop at that and say, it is what I'm describing of, obviously, as you well catalog, the ITU work, the 3GPP work, and then national, like at the FCC and other national spectrum regulator. Do you see all of that work happening kind of in conjunction with one another and kind of on parallel tracks, meaning that we are going to start to see the spectrum track, ramp up as the ITU and as the 3GPP tracks also heat up?
Yeah, so let me start. So I think you're exactly right, Dean. That all has to happen in parallel. And with the work starting with the vision in the ITU, that'll be complete next year, and the World Radio Conference, which will look at spectrum items next year as well. That all has to happen, and that will happen in parallel with the 3GPP evolution and 5G advanced and beyond, the ITU work. And again, I don't want to restrict this to 3GPP. There are other standards for that are also addressing, quote, 6G, whatever that happens to be defined. So there are a lot of moving pieces, and yeah, there's a lot that's going to happen in parallel to get us to converge on a 6G.
Dean?
Yes.
It's Dick. Yeah, this is a really complicated parallel path moving forward. And
yeah.
I'm wondering, do we ever coordinate with the State Department? I mean, obviously the State Department sends delegates to the ITUR.
Sure.
And then the second question is, I wonder, we can, as a group, we can submit something to the State Department to go to the ITU about generally what we would like to see in the planning for 6G. I guess the question is, do we need to think about things like that? Is that useful? What do you think?
Yeah, so I could actually start with that, and Brian and Manu, feel free to come on top. So the short answer, Dick, is absolutely. The State Department, in their role as representative to the ITU, their coordinating role, because it's an interagency effort as the U.S. develops its positions to the ITU. So Dick, for every WRC, there's a whole FCC prep process. Jennifer Manner and others know this quite well and are major players in it. So there's just like the TAC, there's another advisory council convened by the FCC that has a whole set of working groups that marry to as you know, for the WRC 19's agenda was set in 2016. And one of the most important things they'll do in 2022 is set the agenda for the next WRC. So the short answer is absolutely, totally right. And the FCC itself convenes a whole advisory committee process for that's focused on WRC 23. And yes, that's a part of the mosaic that we have to pay attention to. I agree.
Yeah, if I could just start, Manu, I'll pass it to you in a moment. Yeah, so to expand a little on what Dean was saying, when we look at the ITU, it is a organization under the United Nations, right? So it's more of a treaty organization, whereas when you look at groups like 3GPP, they're industry-driven specification development groups. So yes, definitely the State Department needs to be involved in that ITU process because of the treaty implications under the United Nations. So, and that's one reason why the ITU develops the radio technology visions and also the spectrum positions, because that's done on an international basis, supports international roaming and things like that. And then the 3GPP develops the specifications to meet the ITU requirements, which is that feedback cycle I briefly mentioned earlier, where Canada technologies get submitted back to the ITU for consideration of the IMT recommendations. So it's a complicated process. Yes, there's governments involved when you're talking the ITU. It becomes industry involvement when you're looking at 3GPP. That feeds back into the ITU process. One of the charts I had, I didn't go through the particular picture, but that highlights what's done in the ITU versus what's done outside the ITU. Sorry, Manu, go ahead.
No, all I wanted to say is, yeah, the only thing is this is still, I guess, looking at that evolutionary path, right? I think what I just want us to say, we don't want to lose focus, and I think the membership does talk about, the revolutionary path, and what does that actually mean? So whether that comes through these ITU 3GPP's regular, occurrence, or does that take shape of something different with the large variety of stakeholders who've started to lay claim to mobile telecommunication and are sort of moving in. So that's the only thing. I just, we want to monitor both here. Now, where on the USG side, on the revolutionary path, if there is any entry point, remains to be seen, but that is something that still, we're really carefully just observing on.
Yeah, and the one thing I'll just point out to that is again, I mentioned it on the one slide, is we want to make sure we understand what fragmentation risks are there as we look toward future technologies as well, and avoid that fragmentation. So that's another complicating factor that this parallelism brings in. Yeah,
right. Yeah, that's parallel path. But I really like the idea of dividing it into two strategies: revolutionary and original. And what I was thinking, and maybe this is not possible, but the State Department actually establishes the U.S. policy on these issues, and I'm thinking we ought to somehow coordinate what we think we want in terms of spectrum needs and so on for 6G to them. Now, maybe that's too complicated and out of line, and maybe it's not the revolutionary path which really may drive this. But anyway, it's a thought, and I just put it on the table. I don't know what to do with it other than suggest it.
Yeah. I think Henning had.
Yes, Henning.
Yeah, thank you. I wanted to follow up on that very recent discussion, because I'm trying to visualize better what a quote revolutionary path would look like. So two that I can imagine. One would be more technologically revolutionary, kind of in the line of new radio for 5G type of thing. I mean, fundamental, or a significantly different radio architecture, modulation, whatever, numerology, whatever, but non-backward compatible in that. And the second one, there doesn't seem to be much appetite for that. The second one would be look at a different model for how this is organized as an architecture. My perception is that even in the revolutionary model, the notion is generally you have typically nationwide carriers, often country specific, but not, I mean, in some countries or regions, more international, who deploy infrastructure and so on, versus a model that is more decentralized, if you want to call it that. So I wonder if the working group has been thinking about what, quote, a revolutionary architecture or might look like, and whether the stakeholders that are dominating 3GPP might be interested or actively disinterested in any such revolutionary architecture, since it would probably not be in their business interest.
Yeah. I don't think the premise of the non-backward compatibility was, taken into consideration. I think it was more on the technology. So you did say that yourself. You qualified by saying, yes, look at the component technologies, look at the new novel architectures, and then how does that come? But at the end of the day, for global harmonization, standardization, I think it will have to coalesce or sort of meet back in. So this is sort of that double diamond approach where you may diverge, but then you have to converge back. And that's just, again, opinion at this point, conjecture at most. But I think we just want to continue to go down understanding better the component technologies, the novel architectures, and still at this point, as you understand, it's very foundational research oriented. I don't know, Brian, did you have anything to add to that?
No, nothing further. I think you've covered it.
Nice.
Yeah, just a footnote to that. I always think it's a mistake to let the backward compatibility drive the whole process, especially in a technologically evolving world like this.
Yeah.
So I think it's always good to look at the components that are necessary, and the other kind of advanced technological issues that are going to be important here, and look at that separately, and then later on figure out what the compatibility issues are, just for what it's worth. Thanks.
Oh, Dean, you're muted, sorry.
Sorry, Ron Rapazzi, I think, had his hand up.
Thank you, Dean. I yield to the other participants. My question was answered. Thank you.
Okay. Back on, I'll say one more thing on Henning's question about what it could be entailed by the revolutionary path. And I think part of what could be designed will flow from, if we have spectrum at 100 to 300 gigahertz, it's definitely not at all clear that what the regulatory paradigm would be for that. Doesn't seem at all clear that it would be the same kind of regulatory paradigm that you would have in today's low band and mid band spectrum. And so a lot of revolutionary governance type stuff could flow directly out of that.
I think Mike had a question.
Yes, I just want to follow up on the comment about revolutionary versus evolutionary. And I guess I do think, as Ms. Nemmer saying, you have to pick one. I think at least the way, for example, the Next G Alliance has been looking at this, you can establish a vision, right? And it could be some level of combination of revolutionary and evolutionary. But you shouldn't pick one, I guess, from this initially without thinking first, what are the vision, what are the goals, what is the roadmap, and so on. So this is a response to the previous conversation.
Yeah, no, further on that, Mike, the ITU process is set up so there isn't just one winner either, right? Any technology that supports the vision and requirements that come out for the IMT can be submitted to the ITU for evaluation and be adopted as an IMT technology. So while, I mentioned the 3GPP process quite a bit in submission to the ITU, it is the potential that other technologies could also be submitted to that process and be an IMT technology as well.
We had one more, Ted.
Yeah, hi. I'd like to propose on the rural, the last slide where we talked about recommendations for rural. I just didn't see on the list spectrum allocation. Well, two things. One is a low band spectrum allocation. We all know the propagation characteristics of rural and penetrating foliage, et cetera, and some of the terrain out there. And then two is access to the spectrum, where, typically CBRS did a great job of not doing this, but typically large operators, get the majority of spectrum. So smaller operators who are in more rural areas, A, need access to the spectrum, and B, need low band spectrum. So anyway, just two thoughts for the rural, rural recommendations.
Excellent points, Ted. I think we kind of hinted when we talked about terahertz about the propagation and channel challenges with that. When you move to the rural areas, that's enhanced, because of the environment. So yeah, implicit in the discussion is spectrum when you get to rural, what spectrum is used, and also access to spectrum certainly.
Great. Thanks.
I think Peter Gamble had his hand up also.
Yeah, I wanted to comment, and we can bring this up in the working group meetings. I noticed during this presentation and some of the comments that we probably didn't look at the technologies that people are developing around smart repeaters as much as we could. This is one of the ways to address the network densification as well as the latency issues, and is an opportunity to perhaps change some of the regulatory environment around repeater technology. And we can certainly bring in some SMEs who are extremely well known in the industry to address this. But I saw that as a potential gap that we could work, and as a place where there are some potential actionable items that could improve the network deployment as we move towards 6G.
Yeah, thanks, Peter. Yeah, good idea to bring those in. We'll look toward you to help us bring some subject matter experts in.
Will do. Thank you.
Mike, Peter, and Dick, your hands are still raised. I don't know if you had anything to add or if you want to lower them back.
Sorry,
no worries.
Take it down.
Not at all.
No, mine was intentional. I think one of the greatest contributions we can make to the commission is this is a transition to light almost. If you think about it, and regulatory environment, the network structures, everything will be different as we move into those spectrum bands. And I think a set of recommendations to the commission about how the regulatory environment ought to evolve to handle that, because at least it looks to me like it's going to be quite different. And as you mentioned, relay, the network distribution especially is going to be very different. Anyway, I think the working group already recognizes that. It's just that I'd like to say, I think that's really an important contribution we can think of. Thanks.
Yeah, thanks, Dick. Yes, definitely.
Any other comments or questions? If not, thanks so much, Brian and Manu. Great job as always. And thanks for everything that you're doing and keeping us moving forward on all of these various issues. So important.
Thank you. Thanks, Dean.
Thanks, Dean.
So next is the presentation from the AI ML working group.
Yes, and then it'll be followed by lunch. So Adam and Lisa, you want to take it away?
Okay. So Martin, this is Adam. There will be 4 of us presenting on this. Lisa is going to be the first up. She's, I think, in Australia today. So Lisa, if you could get us started. Okay, Lisa, you're on mute.
Maybe she has a bad connection, Adam.
Yeah, that's possible. Let me just quickly. Okay. Okay, so I'm not having much luck contacting her. Let me pinch hit and start off on the presentation. And first of all, let me thank the FCC, Dean Brenner, who's chairing the TAC, and all of our FCC liaisons who have been participating in the Artificial Intelligence and Machine Learning Working Group. And let me add that we've probably spent the last 2 to 3 years exploring much of this subject. So I think this year allows us to go into things in a lot more depth, and I think very relevant both to 6G, the advanced technologies, and spectrum sharing. So if I could go on to the next view graph, please. Okay. I'm not going to spend a lot of time on this. We have quite a vigorous group of members who have been participating both in the working group and the sub-working group. If I could go on to the next view graph in that case. And that is to talk a little bit about the agenda for today. What we're going to be doing is talking about the charter, just a quick walk through it, the approach that we are taking, the activities to date, a very important part that was part of the charter, and that is the safe uses of AI, where we have formed a sub-working group where Michelle Thompson and Paul Steinberg are heading up for us. A little bit about the results and products, and then lastly, summary and discussions. There is an appendix you'll find in the deck that describes some of the speakers that we've already heard from and those that are scheduled. Let's go on to the next view graph, please. So what I'm going to do next is walk through the charter, the next view graph. Okay, we had 5 items that were handed to us by the FCC. The first one of those was a follow-up on something we had done in 2020, little hiatus when we had the epidemic, but that was to propose a number of pilot projects for the FCC that dealt with the use of AI and ML, sort of capacity building within the agency. And you will hear a little bit more about that as we go on in the presentation. The second one was to explore the use of AI and ML to improve the utilization of spectrum. Everything from, okay, I'm hearing a little bit of a background. Yeah, I don't know whether Lisa is connected or not. Okay.
I'm here, but continue, Adam. That's fine.
Okay, can I hand over to you?
Sure.
Okay.
So, the second, explore the use of AI ML methods and techniques to improve the utilization and administration of the spectrum. Next slide, please. Next slide. I don't see the slides advancing. Is that my connection?
No, it's not. I don't see them advancing either.
Yeah, there appears to be a bit of a lag that Martin is working on.
Okay.
Adam, why don't you continue in case it's my network?
No, here we go. It
Oh,
just
okay.
flipped.
Thanks. Topic 3, evaluate the use of AI ML methods and techniques applied to assuring the safety, security, and performance of the network equipment, network control, and network operations in the network environment that increasingly relies on automation, seeing the rapid growth of network connections and digitized and softwareized. And 4, consider the implications of the AI/ML adoption by continuing by content providers and the impact on consumers, focusing on the understanding the causes of and approaches to dealing with addictive behaviors. Next slide. And the final one, excuse me for 1 minute. Thank you. Formulate a better understanding of the uses of AI/ML that may result in modification of human behavior to develop sound policies that encourage positive outcomes and mitigate against negative outcomes. Next slide. So here we go with the approach. So let's go on. So we took those 5 items and we organized them as 4 broad topics. So in the ways that we could address them through the speakers. So the first one was we covered AI ML pilot projects for the FCC. Topic 2 was safe uses of AI. Topic 3, use of AI ML and computing for spectrum sharing. And topic 4, use of AI ML in telecommunications networks. Next slide. In its approach, we considered the questions and issues posed by the charter for FY 2022, the alignment of the effort with the current strategic priorities. So that was the digital divide, the innovation and economic growth, protecting consumers and public safety, and efficient use of spectrum. So that's the way we took the topics and aligned them with these priorities. Third, the trends and patterns in the adoption of AI techniques and solutions and their effect on the mission and responsibilities, the adoption of AI by operators and how it impacts network performance, control, management, and the needs of the consumer, as well as commercial applications, and the implications for future network architectures and network demand for services resulting from the widespread adoption of AI. Next slide. In its approach, and we'll continue this, input in the form of presentations and discussions on various aspects of AI as applied to issues that affect telecom networks, including projected advances and current results of AI and ML applied to technical aspects of network resource allocation, technical performance operations, the impact of AI ML on business models, and the legal landscape for dealing with AI impacts on safety, security, privacy, sensitive private information, data sharing, and issues of fairness and transparency. The fifth was a broad look at the state of AI and ML technologies and the practical issues in operationalizing AI solutions and developing an ecosystem, and also coordination with the other working groups. Topic 3, the SS working group, and with other working groups on topic 4. So next slide. So our methodology was much like we had in other years. So we addressed issues. We had several that I just mentioned. We evolved that into considerations, looking at the priorities, industry trends, maturity, timeliness, and impact. We took inputs, the SME discussions, external presentations, documents, and liaisons, and then came up with the recommendations I just mentioned to come up with priorities and industry trends. Next slide. In its approach, we actually are looking at the futurescape. So where does AI, ML, and computing play a significant role? So we look at the problem space, if you look here on the left, and then the overlaps on how do we solve it. And you'll see we're looking at several things: the methods, sensing, emulation, simulation, analytics. It doesn't completely overlap because you have a problem, but there are some solutions that actually provide more capability than maybe what the problem states. And so we're being very open-minded in that area. So next slide. So Adam, I'll turn this back to you and we can talk about activities. Adam, I think you're on mute.
Off mute. Thank you. So let's go on with the activities to date. So the first thing is we do meet weekly as a working group, done 4 to 5 o'clock each Wednesday. I think the other working groups do something similar. We have a sub-working group, as I mentioned previously, that's Michelle Thompson and Paul Steinberg. They have a meeting on Thursdays, so 2 meetings either every week or every other week. And at this point in time, we have had preliminary discussions and input that has, in fact, addressed all 4 topic areas, some less so than others. But the first one was an understanding, I think, a discussion with our liaisons, looking at the AI and ML pilot project for the FCC. I think we started both discussions and hearing from SMEs on safe uses of AI, a considerable amount of spectrum sharing, and then lastly, really concentrating on AI and ML for telecommunication networks. Let's go on to the next view graph, please. So I think in all of this, we have quite a slate of targeted speakers to address the topics that are in front of us. And in the first one, I would say we've had initial discussions. I think what really came out of that is an emphasis of using of AI and ML either for Open RAN, and I think what featured very prominently in the discussions was the importance of using AI and ML to address propagation models and how those can be translated into actual policies and regulations that might allow you to actually solve quite a few of the problems in front of the FCC. On topic number 2, we will actually have a briefing by both Paul and Michelle, so I'm not going to say anything about that. On topic number 3, which dealt with spectrum sharing, I would say it's the importance of transition to actually dynamic spectrum sharing, the importance of propagation models and how those play, and where AI and ML can actually change the game, making the use of sharing much more efficient and much more dynamic. On topic number 4, which deals with the network, how can AI and ML fundamentally affect future networks? So we are going through an exercise we call a Futurescape for the Converged network. And that last item has really been our main activity to date. Let's go on to the next view graph, please. So what I'm going to concentrate now is sort of a look at that Futurescape for the Converged network. I think this intersects with the spectrum sharing group. I think emerging technologies and 6G in many ways. And I think we have good representation from those working groups in how we are approaching this. And so the first thing we started to take a look at is what problems is it that actually needs solving, looking at our charter, looking at what's going on within the other working groups. A very important one, sort of a view from our membership in the working group. What do you expect the future network to look like some distance forward, whether it's 6G, whether it's the use of the emerging technologies, how will the architecture functioning of that future network be like, and what are the underlying technological advancements that are driving that. And then we also took a look at what will be the specific parameters and characteristics that will be different in future networks from what we have today. We still have in the pipeline sort of to gather the assumptions and that accompany items 1 through 3. And then lastly is really, I would say, sort of the meat output from this working group is where can AI and ML, and I would like to really emphasize this, resolve problems and contribute to solutions, okay? Not necessarily just pure AI or pure ML, but AI, ML, and computing in conjunction with other technologies and other techniques that are available to solve these problems, okay? And I think we've heard from quite a few speakers already at this point, and they've all said, if you want success with AI and ML, get your problems to be specific enough and in some sense small enough that you can actually conquer and get good results out of them. So let's go on to the next view graph, please. So what I'm capturing here is something at a fairly high level from the discussions we have had. What problems need solving? So the first item that comes up are large-scale national and societal problems, whether it's the digital divide, whether it's economic competitiveness, or things at a very specific level, the transition to electrical vehicles, and at the same time, autonomous vehicles, education, healthcare, law enforcement, a lot of sub problems under that. The next thing is that if you take the trends in what the network looks like, how many parameters are actually necessary to define the state of the network. High level, we would call this taming network configuration management, and because eventually that leads to the efficiency of the network, the KPIs that go along with it, so a very, very big area. Achieving competitive network performance and efficient use of resources, obviously, as mentioned in several, in that first 6G presentation, the whole bundle of security, which involves privacy, trust, and assurance, that it follows the rules it ought to, the users do trust it, and it's there when it needs to be. So part of that may be security for supply chains, things of that sort, as part of that. Big area, network management. Again, I'm not going to say a lot about this. Okay. And then the last area is sort of the technical aspects of network design, deployment, operation, and performance. And I think all of this leads all the way through the life cycle of the network, from the design of the components to eventual retirement and service. If we could go on to the next view graph, please. So in terms of what folks perceived as that network of the future, I think very much in line with, again, the 6G presentation, is a very high degree of automation, and understanding that the network will be heterogeneous, that'll have ubiquitous coverage on cellular, but interoperable with other modalities, whether they're satellites, wide area networks, point to point, fiber. I think all of those have to be considered in thinking about that network. And in some sense, the challenge here is, how can you deal with the complexity of what we're seeing in the network? Because AI and ML may be able to help with a lot of the issues that are there. The next item was distributed access endpoints everywhere, high bandwidth everywhere, replacement of hardwired infrastructure and wireless connectivity where possible, but at the same time coupled with more extensive use of that hardwired infrastructure, whether it's fiber, cable, or satellites. If we missed in including that, okay. Really, how does everything play together in a network that has all of these modalities in it? The next one is a perception of moving away from geographic licensing of spectrum to some form of much more dynamic spectrum sharing with real-time policy-based assignments. And the last one is, if I were to do an analogy, sort of a plug-and-play like network, as opposed to one run by operators, much more like the internet in some sense, where it's easy for people to hook up to the network. And this is where things like Open RAN and so on play a significant role. So if we could go on to the next one, please. And then taking a look at very specific parameters. I don't think we're quite done with this. But the first one is very high spectrum efficiency. We've had things like massive MIMO around for quite a while. As we start looking at the higher frequencies, millimeter waves, terahertz waves, things of that sort, how do we get the number of bits per hertz up in the network? And do it in a way that's manochable, higher bandwidths, latency. I think if I take a look at the world of applications, since we seem to be moving towards policies where a general purpose network serves all comers as opposed to assigning spectrum for specific uses, again, fairly important. Coverage, I don't think we have ended up at the right parameters at this point as yet. But if you look at the deployment of the Internet of Things, transportation systems, autonomous cars, area coverage becomes a lot more important. And at the same time, bits per population per hertz. And lastly, a little bit of novelty here, looking at security and privacy of trust. Looking for measures of saying, are we falling back? Are we actually making progress on the solutions that we are finding? So a notion of saying, hey, when we transmit bits, How do we know that they are validated, good bits, as opposed, okay, as a fraction of the total number of bits that are transmitted? Are people paying attention to security, privacy, and trust in an appropriate way? Can we identify what things are? Things along the same lines. So if I could go on to the next view graph, please. So I think, in doing this, we have quite a few experts within the TAC, as the chairwoman said, I think in her introduction. But we also have a great slate of folks who can inform us, who are experts on various subjects. I'm not going to go through this in great length, but we have Darren Osamoglu from MIT. He has written an influential influential article on the harms of AI and ML. We have heard from how the EU is dealing with regulations, because I would say AI and ML seems to be a favorite of legislative bodies around the world at this point. The issue of ethics and how it's used, the importance of open source, security, the network itself, propagation, looking at clutter models, things of that sort. If I could go into the next view graph, please. But again, I think we've just had two very good speakers, Randall Davis from MIT and Stuart Russell from Berkeley, looking at sort of the future safe uses of AI. Experts from Nokia, Cadence, looking at the basic tools for design, things like filters, because one of the problems that we'll be facing is how do you avoid interference, and so on. So I think a good slate. Again, if you have people you feel we ought to hear from, please propose, and we'll be happy to take those suggestions. Let's go on to the next view graph, please. Okay, so what I'd like to do at this point is actually hand over to Michelle and Paul Steinberg. They're going to tell us about the activities of the sub-working group on safe uses of AI.
Well, thank you, Adam. I would like to defer to Paul if he'd like to make an introduction.
Can you hear me now?
Yes, you're coming through loud and clear.
For some reason, Teams decided to stop using that microphone, so I switched to a different one. So my apologies. Thank you, Adam. I'll get us going here. Before we jump in, I guess one of the things, because we don't have a specific acknowledgement slide, I wanted to underscore what's been said many times, the importance of our FCC liaisons. This is such a broad, complicated, and I would say charged topic that having their constant counsel and collaboration in terms of how to focus the work is super important to getting to a good outcome. So I just want to thank them for that and for the future collaboration. So if you could go to the next slide, please, Martin. So here, just a subset of the broader work group that Adam and Lisa overviewed earlier, the folks that are contributing specifically to this activity. So I won't belabor this. You've seen these names already. Thank you. Next slide, please, Martin. Adam and Lisa overviewed the specific charter topics that the FCC gave to frame out the work of the AI broader working group. And this is just kind of showing how we've kind of scoped the safe uses component. Michelle and I have kind of gone through those. And we see that with charter item number 3, which is really more around the network operations and optimization of the network, the safe uses component is a support aspect, meaning that it's definitely a fundamental consideration that has to be thought about there. For the last two topics that were framed out for us, though, which were really focused on artificial intelligence and machine learning, having some exploration of impact on consumers and what that might actually do to influence them in the negative, and then also the last charter item was around the idea of ways that we can maybe leverage and exploit AI and ML to encourage better outcomes and mitigate the negatives. So sort of the pro and con there. So that's how we've kind of used broadly to scope the function of this group. I should have said up front, we've been operational for about two months or so. We got kind of a little bit later of a start, so we're going to have to run a little bit harder to get to our objectives that I'll show you at the end. Next, please, Martin. So this is kind of one way we think about this at a broad level. And I think Manu and Brian brought out a lot of what I would say here in the 6G talk. But if you think about the interrelationship at 100,000 feet of network computing, which is rapidly becoming cloud and virtualized, and then sort of the application plane. I think in the past, what the network sort of existed to interconnect the computers, and the computers sort of relied upon the network to leverage information, and the applications ran on top of that. But I think the world we're in now is the network is increasingly defined by and embodied as software. The software-defined networking, network function virtualization, so ORAN being sort of a very obvious but extreme example of that. And maybe in the limit, the network becomes simply the modulation, the physical interface, the modulation of waveforms, or injecting light into fiber. Cloud becomes ever more important because it not only is the compute platform, the data storage platform, but it's also where the network lives, resides, and takes form and function. And AI is not just an application that runs on top of that copious interconnectivity and that copious compute and data storage. It's increasingly going to play and is playing a role in driving the functionality of the compute platforms, to optimize them, to protect them, and also driving the network. And Adam overviewed a few of those topics from the perspective of optimizing it, both maybe from a spectral point of view, from an energy point of view, protecting the network and directing it. So what I think has happened is by moving all this to software and by compute becoming available at such scale, there's a very intricate relationship between all these topics. I think it's incredibly prescient of the FCC to recognize that and to charter us to move this ball forward. So the interdependencies are complex, but ever more important. So next slide, please, Martin. Adam mentioned that one of the groups we'd heard from is the Information Technology Industry Council. So that's a group that's based primarily out of the EU. And we had them come in and brief us on the work that I think it's probably around 18 months now in process that the EU is doing around regulation of artificial intelligence and machine learning. So one thought when talking to a group that thinks about regulation such as the FCC was, let's see what the rest of the world is doing, how they're thinking about this. And so a few things that they shared with us, and this is at a very, very high level. First of all, it's still very much in progress. It will probably take years to ultimately culminate by the time it works its way through the parliamentary process as well as the regulatory groups within the EU. But it's a few key broad level topics, and I'll poke in a little bit more on this in a second, is they have a very expansive definition of artificial intelligence. And that turns out to be a very controversial topic in and of itself, in terms of if you're going to place some rules around something, you have to be very precise about what that is. And that's proving to be a challenge. The intent here is very broad, and it's cross-use, cross-industry. So it's certainly not just focused on networking, not just focused on critical infrastructure. And one of the key tenets of what they've done is what they refer to as a risk-based approach. So the tenets of that are identifying unacceptable risk, high risk, limited risk, and then ultimately minimal risk. Next slide, please, Martin. So their definition of high risk is, as you might imagine, anything that involves safety, whether it's contributing to safety or whether its fundamental operation is relied upon to ensure safe operation. Or if it's actually just intended to be a safety component of a product. The third-party conformity assessment is one of the things that they're actually looking at to try to dig into that. So some of the broader high-risk use cases that they've identified, and you can see that they're very, very broad. biometric identification of people, anything, as I mentioned before, safety components of critical infrastructure, and that, well, they don't necessarily in all cases call out communications. That's certainly one. Access to services, recruiting, work-related decisions, making decisions about people, healthcare, credit scores, even deciding who gets emergency response at what priority. Law enforcement, which is near and dear to Motorola, predictive policing, sentiment analysis, and emotive recognitions. So you see that they've kind of identified a lot of these high-risk use cases, and they're trying to build legislation and regulation that kind of encompasses all of those. So Martin, if you want to go to the next slide, please. So what our approach is, and as I mentioned before, we just kind of got started here and have gotten some of the first topics kind of coming in, but we're kind of at Q2 meeting today. We'll expect to bring in the industry briefings probably through the third quarter, toward the end of September. Definitely where we can find existing regulatory frameworks and best practices, such as what we saw in the EU, we'll continue to assess those. Bubble this up to try to then identify the implications for policy and framework, to try to thread that through, because we think that's definitely of interest to the FCC. But the content, the output is in the top two rows. So first will be to identify the safe use considerations, try to work through risk assessment practices, such as a risk-based framework such as the EU is proposing. And then finally, to make some suggestions around mitigation measures. And I think the output is, our current thinking is there'll be some informative content. So think like white paper or slide presentation that kind of encapsulates the background of what we learned about these and what the work group develops. And then of course culminate that with some actionable recommendations that'll funnel up into the broader work group activities from that Adam and Lisa are leading. So that's kind of a very quick introduction where we're headed with this. Hopefully that gives you a sense. Michelle, anything please to add? Otherwise, I'll turn it back to Adam and Lisa.
Okay.
Oh, sure. Thank you. Thank you so much. It's an honor to be part of a very important process. I'm the co-chair for this particular sub-working group, and I advocate for the value of open source and open access, and how it can help allow our commercial sector to focus more powerfully on business differentiating goals and not waste time reinventing the wheel. And that is a big deal in AI and ML. And thank you. Back to you guys.
Okay. So I think at this point, Lisa is going to do the back end of the presentation on what we expect our results and products to be. Lisa?
Yes, great. Thanks, Adam. I'm going to power through here and get us to the end in case we have questions. So let's go on. We want to talk about results and products. So let's go on. Yes. Recommendations. So these are the things that we plan to produce this year. So a draft for third quarter TAC, final for year-end TAC. So we plan to bring in draft recommendations next quarter for review and some comment. We want to cover all 4 topic areas. Briefings, so a detailed summary and background for each topic area. Summary and expected advances in AI, ML, and computing for telecom and networking. And a summary of the landscape for safe uses of AI, ML. And thanks, Paul and Michelle, for that great review that you've already provided. And finally, a brief white paper, a pilot project for the FCC. So we want to cover that in a little bit more detail this year as well. So on pilot projects, a description of the rationale, scope, approach, required resources, and objectives. Next slide. So summary and discussion as we finish up this section. Next slide. So we're still early in the game. We've had some useful input and discussion so far. We've got initial thoughts collected, which we've shared here today. We still have a very vigorous schedule of SMEs to hear from. Very excited about that. A preliminary sense of the significant issues. So sorting out perception of what AI/ML can do and what it cannot do for telecom and for the FCC. Again, the focus is a very important thing as we're looking at this group, because as we all know, AI can cover many different areas, and we want to retain a lot of focus. Initial identification of important areas with current and future impact on FCC, and the third one, data, and data. In 2020, our recommendations we had a lot of data in the recommendations, and that continues to be an area of high interest for us. And we can expect preliminary notion of observations and recommendations by the time we have our next TAC meeting in Q3. Next slide. Thank you. And with that, I will conclude and see if there's any questions. See a hand raised.
So I see Henning with his hand up.
Yep. Let me turn on my mic. Thank you. Two questions, namely, one is a scope type of questions, namely, in other industries, let's say airlines being a famous example, but credit type of, you mentioned that indirectly, and you personally, the presentation mentioned it indirectly. Also one is I wonder if the group is also looking at the use of machine learning to possibly tailor offerings of communication products to, in particular, households. So you could well imagine differentiated pricing of communication services based on the characteristics of a household. Given how much data is available on that, that my offer would be different than your offer would be, which raises the usual equity and other concerns for a, quote, utility type of service. In that. So that's my first question. And the second one is,
why don't we actually maybe answer that, okay? Because I think you hit a very important topic, okay? In the following way. If you look at communication services, I think this was our conclusion in 2020, they are interwoven with computing services, and AI and ML are part of those. They are interwoven with where we store data and how we move it around, okay? And in fact, a lot of the end value that consumers enjoy and that are enjoyed by industry, okay, actually come from the treatment of, I would say, the use of those other infrastructures, okay, as they are bundled with communications. It also shows up, I think, in the picture that Paul showed, that there's a very intricate balance, okay? And so when you start looking at that, what you quickly realize is that the use of AI and ML changes the communication patterns, the data storage patterns, the CDNs, things of that sort in a very fundamental way, okay? So one can go on. I mean, this is a terrific topic, and it's very much part of our focus, if that's what you were asking.
Yeah, so I'm particularly focused on the consumer protection aspects, not of the technical, so to say, internal network operations.
But up saying, hey, I'm going to offer you a security package that's based on AI and ML, et cetera, okay? How do I actually exercise that and make it work without blowing up the exposure surface? Okay.
Again, I just want to emphasize, I'm not concerned about the technical narrow aspects, but I'm going to offer you a particular service, and I'm not going to offer, let's say, Lisa the service because my AI determined that she would not be as good a customer for that. Sorry, Lisa.
The next digital.
Just blame ML. And that's, I think, as a role of the FCC as a consumer protection agency, I think is an important consideration. We've assumed largely that pricing, particular and offers are largely universal in that. That may no longer be the case. Again, if we look at other industries in that.
Yeah, and so the place we would put this is the use of AI and ML. I think we were quite explicit on it and how they affect business models.
Yep. Okay.
That's on the list.
Good. The second question is, I wonder if the group has been looking at how maybe external entities have used some of the existing data for in machine learning or type of context. So speaking, so to say, with personal bias, I've been using a lot of the Form 477 data in a variety of machine learning models. You can see some of that published in TPRC, and we found that quite helpful to discover patterns in the access data that normal statistical analysis, correlation analysis wasn't as good as teasing out in that. And so I wonder if the group has been looking at how maybe outsiders have been using existing FCC data sets to extract value using machine learning techniques on that.
So the answer is, when we take a look at formulating a project for the FCC, which was our task one, okay, we actually want to build it around something where they have access to data, okay? So again, you're right on the, on the right track with this, okay? We haven't done, we're not, I would say, doing any of the work, but that focus of trying to understand what data is available and what's not, okay, and how it can be exploited, very much part of the plan.
Thank you.
Okay, and by the way, some of it is that 477 data and things of that sort, and the MLB program. So yes.
So Adam, I see here Alyssa has her hand raised and has for a while. So
sure,
let's take a question.
Yeah, thanks, Lisa. Thank you for the presentation. Just a couple of comments. I think if the working group is going to continue looking at some of these regulatory model examples, it would be a good idea to look at the NIST AI risk management framework, which is in development. Very different approach from the European Union, and probably I think much more on target for most of the telecommunications industry because it's much more flexible. And in particular, I don't know when you had the EU briefing, but there's a lot of different proposals floating around right now for how high risk is defined in the EU AI Act context, including some which would subsume management and control of all digital infrastructure as a high risk use case, which I think quite clearly implicates uses of AI and ML for network management, potentially for spectrum management, for other kinds of uses directly relevant to telecommunications networks. So looking to that as an example is maybe not a great place to start if we think we're trying to be more flexible in the options that people have.
No.
And the other thing that I would say is that with respect to things like the NIST framework, it could be quite useful to work through an example where we actually apply this to a specific network management application that is leveraging AI to do prediction or analysis or something, and show how you would take the steps to do a risk-based analysis. Because I think some of what's missing is that people immediately jump to the scariest cases where you're discriminating against a person based on a protected characteristic or some of these things. And I think it would be quite useful to show how when you take one of these risk-based approaches and you apply it to something which is kind of more benign, what do you actually get out of that? So I would just encourage the working group to sort of hone in on those like very, telecom network specific use cases and see what you get.
No, Alyssa, again, very much right on the money. I think we have the NIST framework as one of the things. I think we had actually a speaker from one of the folks who helped develop that a year and a half ago. Okay, so I think that's very much. Let me just make one comment. I think I'll ask Paul to maybe elaborate on this. We were not exactly thrilled with where the EU is heading, okay, in terms of their regulatory framework, okay? The flip side is, we as a nation have not created any of these large framework regulatory systems like GDPR. Okay? Europe is a large enough market that GDPR is sort of becoming the de facto standard for us and for the world. Okay? And one of the worries is that where they're heading right now, it may actually have some very negative consequences. Okay, and so I think we were reporting, not advocating for what the EU was doing. Okay, Paul, do you want to add maybe a few words to that?
Yeah, I think that's right. I think it's fair to know that. And I think one of the this is Paul's point of view now. I can't obviously speak for the group yet. We haven't kind of taken this all in, but I think one of the problems is regulating artificial intelligence as an entity in and of itself is kind of like trying to regulate water. They've got a lot of very focused regulatory groups that are in context, healthcare, transportation, communications. To me, artificial intelligence is a technology that should be regulated in the context of what's already there, not as a standalone entity in and of itself. So that's why I think, again, back to kudos to the FCC. This is the right place to think about that for the United States, in my opinion, not in a separate body that's sort of making grand decisions about the technology out of context. So thanks for your comments, but and probably should have been a little more negative on it, but I didn't. We wanted to go in balanced and not come out with our recommendations right up front.
Okay.
Yeah, appreciate it. I use that exact line about water all the time. It's really weird. Literally exactly the same. So
I
thanks.
think we have Roger Nichols. Roger?
How's the sound? Can you hear me?
Yeah.
So this is something maybe you talked about and I missed it, but one of my, I don't know, personal agenda topics in this territory is the difference between reality and hype as it relates to especially topics like artificial intelligence. It's one of several. So what is it good at and what can't it do? And so there's a lot of discussion that you have in your plan about, you know, the things like safe use and that kind of thing. I'm assuming, or is it safe to assume that this is going to be done in the context of what the state of the art is for artificial intelligence and where we expect it to be in, you know, I don't know, 10 years or something, because that's it's very easy to think of AI as a solution to everything until you dig in and realize how far we still have to go to get
Roger,
the technology there.
Roger, let me be blunt on it and say it this way. Okay, you know, artificial intelligence is an unfortunate naming for something in the first place. And the level of hype, if you were to look at the Gardner's hype curve or things of that sort, we're pretty close to the peak. Okay. And if I look at the speakers we have had, all of them have in fact cautioned us about that.
Good.
And have been very sane. Okay. And again, maybe it was shorthand for it, but part of I think what would be a value for us to do is to actually sort of do some kind of separation of what is the hype and what is not. Okay, what can you expect as progress? Okay, with some reasonable time horizon. Okay, and what I would say is the titles of the talks that were given to us. I think the first one was Randall Davis that Paul arranged. The title was What AI Can and Cannot Do, and a little bit about what it might be able to do in the future. Okay. And so I don't think we take this sort of blind view that you can magically throw AI at something and magic happens.
Yeah, that's great. I'm glad to hear that that's calibration is in place. Thank you.
Yeah, Lisa, I don't know whether you want to elaborate on that or add to it.
Adam,
but...
I think you said that. I think you said it quite well. And I something that we strive to do and have for the past couple of years, this group has been in place, is to, if I'll say, keep our feet firmly planted on the ground while looking at possibilities.
Perfect. Okay. Thanks.
Okay, Ranveer.
Yeah, thank you, Adam and the team for the presentation. It was very well done. I'm impressed by what you're doing here and really looking forward to the report. The one question, it's related to the previous questions as well, including what Henning and Roger asked, and Adam, you mentioned this as well. My question was less on the negative sides of AI/ML, more on, this entire area is evolving at a very fast pace, and the techniques that are coming up with things like federated learning, transformers, causal machine learning, and we keep, as at Microsoft, we keep announcing the latest capabilities and how it could transform multiple industries. Are we keeping track of the latest developments in this space, even early research, and what the applications of those might be for the future of wireless networks, the telco industry broadly? That's one thing which would be interesting to include in the report as well as the latest trends, because telco is not the first place people apply any of the AI/ML algorithms. One of the techniques we announced was this thing called DALI. The OpenAI team announced this, which, if you look at it, the impact of that on different industries is huge. I'm not sure if you have an effort around that as well.
Yeah. So Ranveer, I think let me do the following. I think you're addressing maybe the following issue and maybe not, but look, when I look at what's under the AI label, there are many branches, not all of them machine learning to begin with. There are knowledge systems, there are natural language processing systems. They all have an impact on this industry. Okay? So one of the things we are trying to do is to figure out how do you do, number one, a balance, okay? And number two, when you look at where the advances are, okay, I would say the best outcomes seem to be when you use AI on a specific aspect of a problem coupled to another technique. Okay? And so we're trying to create that kind of balance in our discussions as we go along. Okay.
That's wonderful, Adam. The one thing I would just add there, Adam, sorry for interjecting, is in the report, if you could also just look at the latest in the academic conferences and just include some terms around it to say these are just, yeah.
So Ranveer, Stanford, I think Yoav Shoham maintains a pretty good inventory of the state of AI. Okay. We also have a bibliography that points to that. Okay. Because I think our capacity to do a lot of in-depth work like this is sort of limited. So we depend on somebody else who we think is pretty good at doing it. Okay. Okay. So I think if you have seen Yoav's stuff from Stanford, that actually is all about what progress is and mapping it in some sense.
Right. No, so the thing that's missing, Adam, is the translation of that to networks. Yeah. And that's the part that I think this working group can address.
Yeah. And that was, I think, the purpose of doing this futurescape exercise is to actually capture that kind of, that aspect of it, okay? Yeah. Okay, I think we had Steve.
Yes. Thank you, Adam. It's great presentation as always. I appreciated your inclusion of satellite in the Converged network, but then I have to admit I became a little confused when you started talking about latency and low latency as a requirement because Converged networks meet all comers. It seems to me that in a truly converged network with AI ML working, that that low latency streams could be split off and that converged network would accommodate that.
That's one of the functions is if you have a good set of AI ML algorithms, I can actually see this working, okay? And you're sending it a payload that has that requirement, it figures out how to route it in the best possible way.
Okay, so perfect. I appreciate that. Thank you.
Yep. Marvin?
Yeah, just following up on the comments about latency, there was a reference to latencies in microseconds. recall that at the speed of light, you can only go 300 meters in 1 microsecond. So that may be a little bit optimistic for
No,
real
Marvin.
world.
Okay, so Marvin, it's not optimistic in the following context, okay? And again, I have no idea where the 6G group will come out on it or the spectrum sharing group. If I were to look at the allocation of spectrum, okay, in some parts of the world, that millimeter wave spectrum is allocated for private uses because it doesn't propagate very far. It's contained within facilities. So when I look at industrial plants where I'm actually doing close control, okay, those people would still like to be able to use the same equipment that you produce in large volumes for other uses, okay? And for them, bringing down that latency is actually significant. Okay, and those distances are, you know, tens of meters essentially. Okay, and the big deal for them is a plant is a lot more flexible. Okay, if I don't have hard wiring to all of my equipment, I can reconfigure it much more readily. Okay, so does that make sense to you, Marvin, in that context?
Yeah, it does. There are parallel problems of how many computer instructions you could issue in response to a communication in 1 microsecond as well.
Yep.
Conceivable.
Yeah. I mean, I look at clock speeds being around, 4 gigahertz or something like that, and you can do an awful lot of instructions before you hit a microsecond.
Okay, Adam,
Okay.
I think we've covered the raised hands.
Okay, Dale Hatfield has one.
Oh, apologies, Dale, sorry.
No problem. Just very quickly, following up, going the hardwired route, though, wireless systems are inherently open, and therefore you may be trading some trading some vulnerabilities in terms of robustness.
Mm-hmm.
And so I'm worried about that trade-off. That trade-off be thought about.
Yeah. No, it's fair point. Yeah.
Thank you.
No, it's a very fair point, and again, if I were to look at an example from one of our speakers, I think it was a DARPA group. Okay, they actually used AI and ML to figure out what was being communicated, who was using the spectrum, and actually characterizing the applications. Okay. Again, as a mitigation against this problem. Whether they'll be successful or not is hard to tell, but that is what they were trying to do. Okay. So you can't just blindly, assume that it will work. Okay. You also have to think about whether it's protectable or not.
Thank you.
Okay. Okay.
Great job, Adam and Lisa. I have one, I guess it'll be the last question, which picks up on a few of the questions and comments that were made after your really good presentation. So I'm wondering if this analogy holds true for AI as well. The idea of evolutionary versus revolutionary, is that maybe a useful way to separate, because we don't want to talk about things that are unachievable or so far off that they're, kind of beyond a reasonable time horizon. But I'm wondering if, taking the way AI and ML is used today and evolving it into doing better things more quickly, new things, versus a complete revolutionary paradigm. Do you see that as a useful way to sort of separate things out, or is that not a useful.
No,
Adam, if I could jump in?
sure, absolutely.
Yeah, so I think that is very astute, Dean, because when we started this line of reasoning in the group a couple of years ago, or maybe 3 or 4 years ago, actually, it is so important to think about what is evolutionary versus revolutionary, so that we can focus on what is near term and doable versus what all could happen in an entire universe. So we need to be tactical and think pragmatically on what we could get done, and that's where the value is. So Adam, I'll turn.
No, it's very simple. So Dean, if you look it up, there is something called Amara's law. Okay, I don't know whether you've come across it, but it says very simply, we tend to overestimate what a technology can do in the short run and totally underestimate what it can do in the long run. Okay. And, if you look at the reality of it, we are trying a lot of new stuff, but the single biggest pieces of progress in AI ML, from what I've seen, are the advances in computing and the advances in data storage and data availability. Okay. You can trace almost every algorithm we use today to something that's 20 to 30 years old. Okay. And so understanding, in a very serious way, all of the technologies involved behind AI and ML in practical ways, there are probably 20 to 30 basic technologies behind all of this. Okay. It's a very tough roadmap to put together. Okay. And every advance means all those technologies have to move up the curve. Okay, and so that is much more evolutionary in some ways. Okay, I hope that answers the question.
No, thanks. No, that was really helpful. Thanks a lot.
Yeah.
Do I see? Is there one other hand up?
I see Marvin's hand.
Oh,
Marvin?
That might be from the prior question.
Oh.
That's a prior question. Sorry.
Okay.
Okay, great.
Okay. Well, no, thank you all for listening to this, and we look forward to working with the other working groups, and hope to have something of value by the end of the year.
Thanks so much.
Okay.
Hey, Martin, could you bring up the agenda slide?
God, amazingly ahead of schedule somehow.
Yes.
So let's take a lunch break. I think we can have a break until 1 o'clock. We'll resume our conversation with Spectrum Sharing Working Group presentation starting at 1 o'clock.
Sounds great.
Thanks, everyone.
Thank you. Okay.
Thanks very much. We are about ready now to start our afternoon session, and so we'll now turn to the report from our Advanced Spectrum Sharing Working Group. Andy and Monisha, take it away.
Thank you, Dean. Welcome back. Hope everybody had a good lunch, and if you're on the West Coast, grabbed your coffee for the rest of the afternoon. The co-chairs of the Advanced Spectrum Sharing Working Group are Andy Clark from the Wireless Innovation Forum and myself, Monisha, from the Wireless Institute at the University of Notre Dame. And we have our very active FCC liaisons, Michael, Martin, Nick, Barman, Bob, and Naveed. Next slide, please. We have a very large group. I think there are about 42 people, and a large percentage of them attend our weekly meetings. This includes the FCC liaisons as well as representatives from some of the other working groups, at least the co-chairs of the other working groups. Next slide, please. Again, just a brief outline of what we plan to cover. We'll spend a few minutes going over the charter. This was presented in the previous meeting as well, but just to refresh our memories as to what we are planning to do in this working group. Some of the topic area updates since we met last in February, the speakers that we've had present to the group, subject matter experts on various topics. And then we'll talk a little bit about the results and work product, and we will take an example of CBRS and looking backwards as to what would we have looked at CBRS if this task group had been constituted before CBRS came out as an allocation in frequency. Conclude with summary and discussion. Andy and I will hand off to each other at various points in the presentation as we work through the topics. Next slide, please. So we had a fairly detailed charter that was given to us. The first bullet basically wanted us to look at the several sharing mechanisms that have already been deployed between various kinds of users, federal and non-federal, licensed and unlicensed, or even among licensed users, long-term goals of these approaches. How can AI/ML, sensing-based cognitive radio techniques enhance effectiveness of sharing mechanisms and optimize network performance? What can we do better given what we have done in the past? And I think the second question here is really important, as we've seen in recent events, that sometimes intraband and interband issues are left unaddressed till the very end. We would like to be able to come up with ways that these can be identified and addressed early in the process. As we look forward to spectrum for next G, be it 6G or beyond, we are looking at more and more at spectrum sharing, which already have incumbent services in those bands. How can these incumbent services be better informed about the nature of adjacent or nearby spectrum environments that may be reallocated to new services? And how can everybody, including incumbents, be encouraged to be proactive in accommodating new spectrum users in environments that are adjacent to the ones that are already deployed, or maybe even co-channel to ones that are already deployed. We've, again, the specific questions about receiver NOIs, we'll talk about that a little bit more detail. What can we do on the receiver side to make spectrum sharing easier and more beneficial to all? And with that is also the state-of-the-art filter technologies. What are the advances there that we can leverage to mitigate potential harmful interference? Advanced antenna systems, which are mostly used to enhance the performance of the system, deploying them, and not as much attention has been paid on using the degrees of freedom to reduce both intersystem and intrasystem interference, and the cost-benefit trade-offs. We all know that we can do a lot with filters, but all of that performance comes at a cost, and how do we make the trade-offs necessary between technology and better spectrum usage? The next item is really to do deep dives into the candidate bands of services that we can look at for future coexistence with perhaps specialized applications such as low power indoor only operation, and what are the sharing mechanisms to consider. Finally, we are also going to be looking at above 95 gigahertz spectrum frontiers. We heard in the 6G and in the AI/ML groups about how beyond 100 gigahertz and into terahertz bands are potential bands for future 6G. We don't necessarily think of those as being shared bands, but they will be shared. There is a lot of passive users in those bands that we have to be cognizant about if we want to allocate those bands for mobile wireless technologies. Next slide, please. So as you can well imagine, given the list of topics in our charter, there is a lot of overlap or synergies with some of the other groups. Here we identify those. For the AI/ML working group,
while there are many broad topics that the working group is considering, as we heard in the previous presentation, the area of overlap with our group is how AI and ML and sensing-based cognitive radio technologies can enhance the effectiveness of sharing mechanisms and optimize network performance. Even today, most of our sharing mechanisms are fairly static. They're based on propagation models. We have not evolved to the point of where we can really use real-time data and AI ML to enhance sharing. Filter technologies has a touch point with the emerging technologies working group. How can the state of the art be used to mitigate potential harmful interference, and the advanced antenna systems also touches into what is being discussed in emerging technologies. And the 6G working group, of course, 6G or next G is all about finding, not all about, but a large part of it is about finding spectrum for 6G. In my mind, we look at two things, the spectrum for 6G or next G and the technologies that go along with it. So we interact with the 6G working group, especially with the spectrum working group in 6G. So we divided up our work into 5 topics, and we'll go through each one of them and give you updates as to where we are on all of them. The first topic that we wanted to look at was really do a deep dive into the potential new bands for sharing. And based on the directives given to us and the statements made by the chairwoman, we chose to focus on the 7 to 24 gigahertz bands, excluding 12 gigahertz, which has an open NPRM around it. We call this the rest of the midband. And what we are doing right now is just looking at which subbands are appropriate for sharing or clearing. Can we extend techniques that we've used in sub-6 gigahertz to these higher bands, or do we need newer techniques? The range from 7 to 24, you're basically spanning mid-band into millimeter wave, and we need to focus on what exactly can work across the span of frequencies. Are there specific types of secondary users in these bands that are most compatible with a given subband? And we also have to look at what's happening in the rest of the world, especially since a number of these bands are satellite bands that are used globally, and some of these bands have different kind of incumbents in other areas of the world. We have to pay attention to what's happening elsewhere as well. Number 3 is I think, it's an open-ended question, which ties into some of the receiver topics that we are also looking at. And the question really goes into is how long should any incumbents, non-DoD in particular, be protected if you're not using non-coexistence? If you're really trying to think about getting new entrants into a band, how do we formulate our protection schemes longer term? What should be the primary coexistence mechanism? We have all of these 4 mechanisms today. Which ones are most suitable for the new bands that we will be looking at? And finally, how best can we share with passive services above 95 gigahertz? The challenges posed by those services are pretty unique. Most of what we have today is coexisting with active services, with some passive services like weather radar, but not a lot. Next slide, please. So what have we done so far? We've had a number of presentations which have really informed our thinking and our investigations. We had a very nice presentation by Mark Gibson and ComSearch on investigations into the 7 to 8 gigahertz band. He presented their results from looking at what exactly is there. The conclusions were that the vast majority of the federal allocations in that band, so 7.125 to 8.5, are either fixed or satellite, and the number of fixed assignments are declining, and approximately 20% of the fixed use is DoD. There's fixed satellite use in a couple of different bands, the 7.25 to 7.75, 7.9 to 8.4, uplink and downlink, and it includes defense satellite communications and wideband gap filler satellites. They did spectrum occupancy measurements for 3 cities and indicates generally low usage, keeping in mind that as we all know that usage is determined by a large part as to where and how often you're sensing. So these preliminary results look like that there is a good feasibility of sharing in these bands, but definitely more study is needed to characterize current use. We are waiting to hear back from NTIA on their usage assessments and update, and we're going to continue to study this band. We also had a presentation from Qualcomm on an experimental license and experiments being performed in 12.75 to 13.25. And this ties in well with some of the 6G discussions that we heard earlier in the morning. So they're looking at 6G terrestrial mobile systems to operate in this band that can use wider channels to provide gigabits per second throughput while providing improved coverage. So that is a band that, I mean, our definition of sweet spot seems to have changed over the decades. And now we are kind of looking at this band as maybe a band that would be definitely better in coverage in terms of compared to millimeter wave, and still provide enough bandwidth that we can do the gigabits per second. There are incumbents here too: federal operations, radar systems, satellite, radio astronomy, and commercial users. Again, a lot of the early work being done here is to look at propagation, to see what coverage can be, to look at channel measurements. But definitely this seems to be a particular slice of the 7 to 24 band that could be promising for future sharing. Next slide, please. We also, on the other upper end of the spectrum, we had a presentation by Phil Erickson of the MIT Haystack Observatory on passive users of spectrum. And he emphasized, I think, why we need to protect these users of spectrum. It is a benefit to society to find out about black holes, and there was the recent announcement of the discovery of these unique, I don't know what you would call them, stuff in other galaxies.
Fast radio burst.
Yeah, but yeah, there is a societal benefit to allowing these kind of applications to continue. The challenges are very different. As the astronomy systems have evolved, they have become more and more sophisticated. They are able to pull signals out that couldn't be pulled out even a few years ago, which means that sharing is becoming increasingly difficult. It is not only in-band signals that they have to worry about, but also out-of-band and spurious emission from adjacent bands. It is the mobile transmissions that are particularly hard for passive astronomy. If you know fixed sources, if you know where they are, it is easier to deal with them. It is the ubiquitous mobile wireless user, which is very, very hard for passive users of spectrum to deal with the increasing deployment of satellites. The problems of passive astronomy have just grown a lot more. So the next steps that we want to do with topic 1 is continue our investigations. So far, Amit from Nokia and I have been primarily spending time in this activity. We've kind of worked our way up to, I think, about 18 gigahertz from 7. It's not complete yet. It's an ongoing effort. We need to get better information on the federal government band used from NTIA, and then hopefully conclude either in the third quarter or by the end of the year on which of these bands would be the ones to focus on for future allocations, given the existing users and the performance constraints of existing users. Next slide, and I will hand this off to Andy to continue the discussion on topic 2.
Okay, thanks very much, Manisha. Hello, everybody. So in the Advanced Spectrum Sharing Working Group, we are looking at a total of 5 different topics right now that we would like to develop and recommendations on by the end of the year. Some of these are related, so I don't think we're going to have 5 sets of recommendations, but the second topic we're looking at is best practices for spectrum sharing. So, over the last basically 20 years, we've had a lot of experience with various spectrum sharing frameworks, and it doesn't really start with TV white space, but TV white space is a well-known example of one of the early spectrum sharing frameworks. And then we moved on to Citizens Broadband Radio Service, or CBRS, and that's already commercially deployed. And we're in the process of developing the 6 gigahertz automated frequency coordination, or AFC system, for allowing unlicensed devices to share the fixed service bands in the 6 gigahertz range. And when you look at how all 3 of those systems develop, there's a lot of commonality in the way those systems operate, and the way they were standardized, and the way they were approved by the government. And so we've now accumulated basically 3 sets of data about what's the best way for this to develop. And so what we're looking at is, can we look back at our previous experiences, and what can we learn from them as far as best practices going forward? So, for example, one of the things that occurs to us, especially now that we're developing 6 gigahertz AFC, is that a lot of the challenges and standards requirements that we need for 6 gigahertz AFC very closely echo some of the things we did in CBRS, which itself echoed some of the things we did in TV white space. So is there a way that we can catalog these commonalities so that we're not reinventing the wheel every time we develop standards or rules for shared spectrum framework? Also, one of the things is that the spectrum sharing frameworks like TV white space, CBRS, and AFC, how band specific do they need to be? If you put on a plot the architecture of all 3 of those frameworks, they're actually extremely similar. And so can you abstract this framework and make these band agnostic, so that as you deploy new shared spectrum operations in other bands, can we leverage what we've already done in the past? But also, one of the things, although it's not really shared spectrum in the way we define shared spectrum, but are there lessons learned from Wi-Fi? What role do contention-based protocols play in successful spectrum sharing? So the Wi-Fi model versus the CBRS model, which is mostly LTE or other systems that don't have contention-based protocols built in. But what can we learn from that going forward? So the other thing is, can we extend the concept of low power indoor devices that we have in AFC into new bands? And in the 6 gigahertz band, if your device is under a certain power or under a certain power spectral density, you have to apply both tests to them. They can be deployed indoors without having to be authorized by a centralized spectrum management system. The FCC, in the course of the proceeding, determined that if you stayed below these power levels, that interference to the fixed service incumbents is not expected as long as your device is inside. Early in the CBRS process, there was a similar concept called Contained Access Facility, or CAF, where if the CBRS device was within a warehouse or office building or something, it might be able to share spectrum better than if you couldn't determine whether it was indoor or outdoors. Unfortunately, in CBRS, that concept was never adopted, but was a very interesting concept and probably in hindsight would have been very useful. The challenge we come up with is, what is a robust method of identifying if a device is indoors? That's not a simple problem. In 6 gigahertz, it's approached from the regulatory standpoint by making sure that a device that's qualified to be an indoor low power device can't be weatherized. It can't have a connectorized antenna. It has to be connected to a power line. It can't be battery operated. And that suffices in the 6 gigahertz case for low power indoors. But if you're not using a device certified for low power indoor, if you're using a higher power device, is there a way that you can automatically determine whether it is indeed indoors and what the indoor loss might be so that you could take that into account in spectrum availability? So I think that's a challenge that we're facing. We also have learned that aggregate interference in the case of CBRS, for example, can be very difficult to deal with if you literally compute aggregate interference from all of the devices in the band into incumbents, because then you have competitors having to share all of their proprietary data with each of the SASs in order to calculate aggregate interference. Is there a better way to approach aggregate interference than doing the actual calculation? Can we estimate it somehow? We've seen challenges related to incumbent sensing, both in TV white space, devices to sense TV channels. Those were never certified, not one ever came into being. In CBRS, we have the challenge with the ESCs interrupting the band itself because you have to protect the ESC sensors from interference. We also believe you definitely need improved or at least validated propagation models for spectrum sharing. We're making modern decisions on shared spectrum based upon propagation models that were developed back in the 1960s. And also, how do we deal with reported cases of interference? Do these centralized spectrum sharing systems, if that's what we're going to use, are they deputized somehow to enforce interference cases or whatever? Right now in CBRS, it's pretty much a case-by-case basis. How do we automate? How do we automate that? And then finally, how can we move to more dynamic operations? Right now, the TV white space, CBRS, and AFC model is pretty much on a 24-hour cadence. How do we make spectrum management or spectrum decisions on a time scale, on the order of minutes or seconds, not every 24 hours? So that's a challenge that we need to face. Next slide, please. So topic update, the presentation that Mark Gibson gave also had his experiences with previous spectrum sharing frameworks. I think he's been through them all. And he helped identify some of these issues that we need to address in best practices going forward. So we'll leverage a lot of what Mark had to say, as well as our own experiences as SAS administrators and AFC operators. So next slide, please. Okay, I think this one we're passing over to Monisha.
Thanks, Andy. So the third topic that we wanted to spend some time on was on receiver standards and technology advances. This was a topic we'd chosen even before the FCC came out with the receiver NOI, and it kind of fits in very well with what the FCC wishes to do in this area. The questions we want to address under this topic is, what degree of interference is acceptable to an incumbent in a particular band, and should the responsibility of mitigation fall on the new entrant rather than the incumbent, even if the new entrant is adjacent channel? And you will immediately say that some of our recent controversies basically fit into this category of who is responsible for interference when it does happen or when it's projected to happen. We had a very nice discussion on harm thresholds, and the discussion around that is, should we, instead of defining receiver standards, define a level of interference that the incumbent must be able to accept?
In Chicago.
And if to do that, how do we account for legacy devices which were designed before any of these receiver standards or harm thresholds came into being? There was also a lot of discussion as can a system such as harm thresholds be practical, because for efficient implementation of the harm threshold concept, you need to be able to capture interference data. How does the victim do that? And how would the FCC validate such complaints and administer harm thresholds? And similar to what Andy mentioned in the previous topic is, what then becomes the enforcement mechanism? Does it become changing the harm thresholds or something else? There are other ways that one can look at to ameliorate interference. Smart antenna technologies can be better leveraged for spectrum sharing. We don't do that very well today. We can use directionality, including directionality of nulling. Most of the work around, say, massive MIMO or beamforming has been to have better link performance of the 5G system itself, looking forward into 6G. And new spectrum, which is shared, perhaps more attention needs to be placed on how these technologies can be used in a different way. There are ways that you can mitigate interference in time and frequency, for example, by active cancellation. These are fairly difficult to implement in practice because you really need to have some level of synchronization between systems if you're trying to do active coherent cancellation. But again, going back to the terms that we used in the previous two presentations on evolutionary versus revolutionary, some of these techniques, if they were mature enough, could truly become revolutionary in the way we look at interference. A topic that has also been called out in the receiver NOI is, are we dealing adequately with different forms of intermod interference? This is a particularly difficult one to address because it's not really the licensed transmitters or receivers that are responsible for interference happening, but a third almost innocent bystander like a rusty bolt or something, which is causing this interference to happen. How do we measure it? How do we deal with it? And finally, who is responsible for mitigating this kind of an interference? We've already talked about filtering and what role they might play. And the question 7 is something, again, that we've talked about, not so much with spectrum sharing, but there's always a trade-off between how much do you share and how much do you increase your risk of security and resilience for both incumbent and secondary users. As with anything, the more you open up your systems to be able to share with other systems, you're becoming more vulnerable to security risks. The final question is, what is the role of industry? As we all know that even though the FCC may not have receiver standards, most industry standard organizations in the mobile wireless industry, be it 3GPP or be it Wi-Fi or other commercial industry, they do have standards. I think a lot of the problem emerges when these systems are trying to share spectrum or coexist with other legacy users that perhaps do not have these kind of standards being developed by industry bodies. And the question is, should industry lead or should the regulation and policy lead? So there is an interplay between how much the FCC should be doing on this front and how much and what role industry should be taking to be good citizens of the band that they've been allocated to operate over. Next slide, please. So on this, again, we've had some really nice presentations. One was by JP DeVries of Silicon Flatirons on harm claim thresholds. And he really laid out the details of how one can think of harm claim threshold, which is that in-band and out-of-band field strength profiles should not be exceeded at more than some small percentage of locations at some statistical confidence level. Now, as one can imagine, that all of these become issues of contention. How do you define this percentage of locations? How do you define the statistical confidence level? But what it does do is move away from being very prescriptive in terms of actual receiver design to being a little bit more flexible in how you define interference. This also ties in with the definition of harmful interference. All interference is not necessarily harmful, but where do we draw the line between interference that can be managed by a system versus one that will really cause harm to the service that you're trying to provide over the band that you're being interfered on? The conclusion was there that you really have to come up with something that is simple to include in rules and measure in the field, and those are both hard things to do. And part of what we hope to be able to do under this topic is flesh out ways that we can actually make some progress on those. We also had a presentation by Preston Marshall on receiver standards, where, again, a lot of the main points were re-emphasized that that establishing receiver assumptions rather than receiver standards can be used for assessing engineering impact. The recommendation was that these should not be mandatory but advisory, and should be modified over time as new technology emerges. We also want to make sure that we do not distort the market unnecessarily by creating standards and setting price points higher than what the market can bear. At the same time, low-cost equipment that would not need to be highly reliable should be allowed to go ahead. There is a lot of innovation that has happened, because we don't have very strict receiver standards. But how do you balance this need for continued innovation versus need for protection of incumbents? We've also spent a fair amount of time discussing the FCC NOI and promoting efficient use of spectrum through improved receiver interference immunity performance. So these discussions will continue under topic 3, and one of the work products would be to come up with recommendations. And I think at this point, I hand it back to Andy to talk about topic 4.
Yeah, thanks, Manisha. So topic 4 is in a way related to all of the other topics, but particularly topic number 2. Topic 4 has to deal with modeling of interference. When we set up spectrum sharing frameworks, all of the rules or the standards that come to be are all based upon expectation of meeting some interference objective. And right now, the models that are used in meeting those interference objectives are fairly unsophisticated, frankly. So, for example, in CBRS and in AFC, the antenna pattern of the interferer is not fully taken into account. We're not using fully two-dimensional antenna patterns, and by two-dimensional I mean azimuth and elevation. So we're not taking down tilt into account. But let alone that simplicity, we're certainly not taking the impact that MIMO arrays and active beamforming arrays can have in terms of limiting interference in particular directions. It's actually kind of a complicated problem, because when you have beamforming, you have statistics about how often your beam is pointing in particular ways. And so then the interference prediction becomes another dimension of statistics that you have to take into account. So how do we model that in shared spectrum environments? we saw, for example, in the radio altimeter discussion lately, these altimeters operate in the 4200 to 4400 megahertz band, and there was concern that the new 3.7 gigahertz service, which operates up to 3980 megahertz, might somehow overwhelm or interfere with the radar altimeters. But we really need to look at these types of things on an end-to-end basis, not just look at purely out-of-band emissions into the radar band or radar filters, but how does an LTE signal interact with a FM swept frequency radar and things like that. We need to look at this as an end-to-end, not just back of the envelope signal level type analysis. We need to put them in the lab and play them off each other. I mentioned already propagation models. In CBRS, a lot of the limitations on deployments are based upon predictions of long distance interference from, say, a troposcatter model. But because that predicts very large amounts of propagation loss, those have not been properly validated because it's very difficult to measure 240 or 250 dB of propagation loss, even though that 240 or 250 dB of loss is not enough to say your device is not going to interfere with a ship 200 kilometers off the coast, unfortunately. But again, we haven't validated that model yet. We're relying on it. We also, are concerned that typically, especially the incumbents, and sometimes the commission, but especially the incumbents, basically want you to assume worst case at every juncture in your interference analysis. And we know from joint statistics that if you base your sharing criterion on assuming the 99th percentile worst case for a series of 5 or 6 or 7 different input parameters, you get to the point where your chance of interference is vanishingly small, but it also highly limits spectrum availability. And so we need to find a way, we need to do a much better way of looking at this from a joint statistical method rather than just applying worst case all along the way. So, that's really kind of wrapped up with how do we deal with statistics overall in the concept of interference. Also, how do we get feedback from real world measurements? CBRS and now AFC are based upon assumptions about interference and predicted interference strength, but how do we get a feedback loop from that? In CBRS, there is no such thing. We don't actually know how much interference is or is not being caused to incumbents. We just, we've done the calculations in spreadsheets and MATLAB and things, and that's what we use in our SAS. But do those predictions of signal strengths received by incumbents, are those holding up? Are we causing interference or not? We haven't gotten any complaints of interference to a protected incumbent, but does that mean we're not interfering, or they just don't, they haven't figured out what the problem is? And if we're not interfering, does that mean we're overprotecting? And if we're overprotecting, by how many dB? Because every time we overprotect, we're wasting spectrum resources. And also, what are the impacts in a shared spectrum environment of the channelization plan or the modulation method, or how you aggregate carriers and what kind of modulation you use? How does that impact interference immunity? Again, it's things that need to be measured in the lab and in the field rather than just done on paper. And I is related to the earlier point, but this all should be based on some kind of solid foundation of risk analysis. And then once we plan some kind of shared spectrum environment, can it be tested prior to letting it loose? Can we share it? Can we test it in test beds? And can we do this without causing a substantial delay in getting to market? But we need to have industry accepted interference models to run these simulations. We need to do lab testing, and we need to do very timely testing with all of the stakeholders, the incumbents and the new entrants, in order to ensure ourselves that interference won't occur, but also be able to move to market faster. So next slide, please. I think just a quick update on where we are there. The interference modeling is really, instead of a standalone topic, it really is things that will be incorporated in our lessons learned topic 2, and also some of our other topics. We have not had a speaker on this particular topic yet. We'll work on having a subject matter expert come in and talk about some aspects of this. But that's where we stand on topic 4. So I think it's back over to you, Manisha.
Yeah, thanks. Again, I'm not going to spend a lot of time on this, but we do want to look at the economic incentives of shared spectrum. Most of us are technologists, and we like to think that there's a technology solution for everything. But sometimes maybe it is more economical when you're talking about impact to legacy systems to pay for legacy systems to upgrade. Is this a viable option in some cases, all cases, nowhere? Those are some of the questions we want to address. And then do a bigger, deeper dive into what exactly are the components of legacy systems that would need to be addressed. We've heard a lot about the lack of filtering in, say, radar altimeters being the prime reason for some of these problems. But are there other issues in designs that are in some cases decades old that need to be addressed, and if they're holding up spectrum sharing? Perhaps the incumbents need to change some of the way they operate. This is always difficult to do because when you've been allocated spectrum, say, five decades ago, and you've built out applications using a certain ConOps, it's difficult to change. But are there regulations which revisits ConOps and the way incumbents are using spectrum every maybe 10 years? And we also want to look at the impacts to the new entrants in terms of economic incentives. If the hurdle to share with incumbents is too high, what does that do with the economic incentive to start using this new spectrum? Next slide, please. We had a dedicated discussion on the May 24th working group meeting. We will plan to include economic incentives in recommendations on potential shared spectrum bands. We have not had a dedicated speaker again for this particular topic, but we do have plans to do so between now and the next tech update meeting. Next slide, please. This is again just a listing of all the speakers we've had, and we've kind of touched on the topics they've presented so far. As you can see, topic 4 and topic 5 was touched on by JP in his, but not a whole lot. But those are the 2 topics that we want to focus on for getting in new speakers. Next slide, please. And now I'll hand it over back to Andy to talk about some work products and a deep dive into some of the bands from topic 1.
Yeah, so we're looking at the moment, we've got concepts for 3 different work products. These are subject to being refined. We haven't finalized our plans for work products yet in the spectrum sharing work group, but our thoughts so far on work products that we will commence on fairly soon is, work product 1 sort of has its home in topic area 1, which is identifying spectrum that might be amenable to shared spectrum based upon a deep dive examination of the non-federal allocations, the federal allocations, and potential harmonization with ITU and other region-specific allocations and 3GPP standards, for example. We're hoping to identify some, potential low-hanging fruit for sharing, particular bands that look like they might be viable shared spectrum, sort of like the fast track report that NTIA did, 12 years ago or whatever, but from the, non-federal side, assuming we can get cooperation from NTIA to get a little more information on their particular spectrum use, whatever they're able to tell us. And so for each of these deep dive bands, we'll look at them from an interference modeling perspective, the economic incentives to share the spectrum, what receiver standards might be required, either industry or regulatory, whatever way we sort of come down on that, and what are the particular technology enablers that will make that band shareable. So if you go to the next slide, please. This would be, pretend we did this exercise 12 years ago before CBRS came on the scene explicitly. And if we had done this exercise some time ago, this might be sort of the analysis we would have done to reflect the CBRS band. And that is, we would have identified 3550 to 3700 as a band that looked amenable to sharing based upon the characteristics of the military radars operating in the band and other incumbents. So we would look at the fact that the primary incumbent is military radar, and those are primarily operating on shipborne platforms, and recognize that the interior of the country was, for the most part, unencumbered. We would, of course, also take into account that when you do a deep dive on this band, even though the band may not specifically show up in the allocation table, you have to look at the footnotes and all sorts of other things. But there are extended C-band receive-only earth stations that operate in this band. And there's also legacy point-to-multipoint broadband systems that operate in the upper 50 megahertz. So we would have had to, from an interference analysis standpoint, taken these incumbent systems into account. The technology enablers we might have suggested to use the CBRS band would be the spectrum access system that manages the devices that are operating in the band so as not to cause interference to incumbents. And that would be the centralized cloud-based system that was adopted. And we also would have looked at one concept for knowing when and where the primary incumbents are operating, in this case being the DoD radar. We might use a sensing capability like an ESC. Unfortunately, in hindsight, that isn't such a great idea, but this is something that we may have put on the table some time ago. We would have come up from an interference modeling perspective with methods to protect the military use of the band without breaking any kind of security type of requirements. So in CBRS, we protect them on the basis of these large geographic areas called dynamic protection areas. And as long as we geolocate their operations to the granularity of one of these large DPAs, they're fine with that. They don't want us to pinpoint the location of a ship to great accuracy, but as long as we say there is a ship within this 200 by 200 kilometer area or so, they're okay with that. And then in the actual CBRS operations, we would protect priority access licensees using these PAL protection areas. And we would do these kind of protection frameworks to ensure that the incumbents and the top tier of CBRS don't suffer harmful interference. So the economic incentives we would have identified is that, for the DoD and for the fixed satellite service earth station operators, they don't have to relocate. They can continue using the band exactly as they are today. There's no disruption caused by a relocation, and there's no cost associated with doing a relocation. For the new entrants, the economic incentive would be that, here's rapid access to 150 megahertz of new bandwidth without having to wait for a relocation of a set of government systems. And, these systems are on the government radars, the Navy radars are typically on aircraft carriers, and trying to re-outfit a aircraft carrier with a new radar system in any reasonable amount of time is a non-starter. We would have learned lessons from the previous spectrum sharing framework, which was TV white space, that regulatory certainty for the new entrants is needed. There's uncertainty about how much spectrum will actually be usable and where it will be usable. It causes the device manufacturers to be skittish about actually developing an ecosystem of devices. But here, in CBRS with the regulatory certainty, we now have 150 plus models of CBRS base stations available. So healthy ecosystem. And then in the receiver standards point, the FCC rules for CBRS actually do adopt a minimum blocking performance for CBRS devices. That really has to do more with their compatibility with potentially high power Navy radars. But I think going forward, we would look at more sophisticated analyses of receiver standards and try to figure out, whether 3GPP or other industry groups might need to adopt certain receiver standards in order to allow CBRS devices to operate properly in the new band. So again, this is sort of a retro look that if we had done this deep dive analysis on CBRS back in 2012 or 2010, this is something we might come up with. But what we're looking is towards the future. Can we analyze other bands and come up with an output like this for certain low-hanging spectrum bands for sharing. Next slide, please. So work product 2 on the lessons learned. In my head, I have an enormous number of lessons that we learned in the CBRS field that could make a pretty extensive white paper. And I know others have experiences in AFC and TV white space. And we plan to capture all of these in a white paper about how these can be applied to future spectrum sharing frameworks. And then the third work product we have on the table, next slide, please, is what we will do with receiver standards. And one of the things we discussed, and this was a very recent discussion just earlier this week, so that's why I put TBD here. We might do a white paper with sort of a meta look at receiver standards, and that is, let's look at all of the relevant industry, government, and academic groups that are out there that are dealing with receiver performance standards, and catalog the existing receiver guidelines and standards. And to the extent that a harmful interference criterion could be considered a receiver standard, look at the huge variety of ITUR interference criteria recommendations that are already out there, and 3GPP receiver performance standards and Wi-Fi receiver performance standards, and on and on. What's out there already, and how are they helping us, or are they helping us? And also, how do these different requirements mesh? Are some of them orthogonal to each other? Does it really promote coexistence or confusion? Really just sort of catalog what's already out there. And how do we treat passive receivers in this range? For anybody who knows anything about a radio astronomy receiver, or a radiometer used in passive remote sensing, or even a fixed satellite service earth station, it's very difficult to put a filter as the first component in your receive system, because a device that is not an amplifier that has any significant loss in it makes your noise figure go through the roof, because you're trying to detect things that are down at the Kelvin level of sensitivity. And as soon as you have a 280K device that has even 1 dB or half a dB of loss, you've added tens of K to your noise, at least, as soon as you put that device in line, if you do it before the first preamplifier. So filtering a passive device can be very difficult. And so trying to levy receiver performance standards on a passive device, it really is kind of a different topic altogether. We'd also want to look at upgrade incentives for legacy devices and things like that, particularly if they're blocking new entrants into the band. And we would, out of all of this, we would perhaps come up with some summary recommendations. Again, this was just very recently addressed in the group just a few days ago, but it's potentially another work product, but it's TBD. And I think that is it. Yes, that is it. So Manisha, unless you have any last words.
No, Andy, we're open for questions. Thanks.
Great. Thanks, everybody. I think, Greg, you've got a question?
Comment?
Yes.
In your description, and I admit to having thought of this before as in our weekly meetings, but a lot of the parameters that you're talking about to get the goal that you want, one of the goals of a seconds or minutes sharing system, seems to coincide with what the AI group is working on. And I just wonder if you could comment on how those two groups can work together.
Yeah, it's an excellent point. In my experience so far, to get down to the point where devices will be able to reconfigure in a matter of seconds is not something that could be accomplished with today's centralized resources, at least not in any efficient sense, because it just takes too long to reach back to a central system, have that central system do some kind of detailed calculation, and then return a result back to that device very quickly. So then you move to a model where you might have sort of distributed capabilities for the devices to make some decisions on their own. The challenges we have there is that can sometimes either come down to sensing, which we know there are issues with, or you've got to build in part of the database on the device itself, which to date the FCC has not allowed, because if you build the database and the decisions into the device itself, then each of the devices themselves have to be certified as an AFC or a spectrum access system or something. And so the certification process gets to be a little more unwieldy. So I think that is where some aspects of AI and come into play. But I think the commission certification framework for devices, if they're using AI to make decisions for themselves, is going to have to be revamped in order to support that type of device certification.
Yeah, if I may add to what Andy just said, I think again, on the part of what are revolutionary ways of doing things rather than evolutionary, those are definitely topics where we would like, at least I would like personally, to see this discussion evolve into. But the hurdle of how do you certify a device? So for example, if we take the 6 gigahertz example, we certify LPI devices by, does it meet these criteria? Is it got a fixed power supply, no battery, no detachable antennas? Very simple to tick off those boxes and certify the devices. Now, if you're saying that this LPI device is going to use AI and ML to figure out whether it's indoors or outdoors, how the whole process of certifying that device becomes way more complicated. And that's where AI and ML can also help. So it's definitely an area where I think, and Adam and Lisa pointed it out, that's one of those areas that the two groups are synergistic, and we do plan to, to have discussions with them as to how do we move this discussion forward.
Thank you.
Thanks, Greg. I think Nomi has a question, or her hand is up.
Oh yeah, thank you. Yeah, I did some work here with Dale Hatfield, who I know will have good thoughts for us on this topic too, a little bit ago. And one of the things I learned, actually I learned this, I'll share the credit with John Chapin. He was sharing with me that the technologies that increase trust, like security and enforcement, are to him like even more important than technologies that increase efficiency. As we look at the spectrum science of this, and I thought that was really interesting, and I wondered how you felt about that, and if you felt our work covered a look at that.
It's a great question. Our work will cover some aspects of that, the enforcement and the trust, and it really is, it's exactly that the incumbent is going to want to feel comfortable that if interference does occur, that there will be some way to address it quickly without a lot of effort. And I have to admit, in the current frameworks of CBRS and AFC, there are ways to address it, but they're not surgical. They're sort of, you basically just cut off access for a device or a class of devices until you sort out the issue. It's very difficult to go in there and surgically fix interference, identify a specific emitter and adjust its power level or whatever. You got to turn off a whole area or a whole class of devices or something like that. So that is an inefficiency in the current frameworks. And I think that sort of comes out in our lessons learned, that the more you can make the incumbents trustful that if interference occurs, you've got a way of dealing with it quickly and efficiently, that will help convince people to share their spectrum much more quickly than telling them that you don't have a plan for dealing with interference.
Yeah, and just to follow up on that, Nomi, there are efforts within NSF to they have this concept of nodes or national radiodynamic zone where these are experimental zones that are being looked at where you can do a lot of this experimentation to really figure out that can you have that loop that closes, that as soon as you detect somebody who's interfering, that you can loop it back to the interferer and either have them stop or locate it and take action. But it's a very important step to really move to where we are now to, better spectrum sharing. And I see Dale, you have your hand up.
Yes, thank you. This will may be a little bit redundant with the conversations that we've had in the working group, but I've listened to the presentations this morning and our own presentation here, if you will. And the thing that I keep finding missing is the issue of intermodulation. For example, when you talk about doing things quickly, identifying sources of intermod takes a long time. And so I'm concerned that we're not addressing adequately the whole topic. Now, let me make it clear. I'm not saying there is a problem here. What I'm saying is we don't know, but because of its implications, I think we ought to be thinking hard about it so we can dismiss it. And of course, I'm talking about receiver mod. I'm talking about intermod. I'm talking about transmitter intermod, and then passive intermod. I have a notebook here beside me on my desk. It's a whole collection of issues surrounding intermodulation in the real world. And it just seems to me as we increase the density of devices, some of them quite high powered, and with a changing environment where two high power stations may jump up away from you, causing interference in your channel could really be a challenge. So I think I personally would, and I've been around a long time. I would, and based on my experience and my knowledge, I think we need to spend some time on this intermod issue, because otherwise, we could end up with a real mess on our hands if it's not a problem. If it is a problem, yeah.
So one of the issues, Dale, I agree with you, but if you take the CBRS band as an example, it's very possible that if somebody suffers interference due to an intermodulation circumstance in the CBRS band, it could be caused by two or more stations that aren't even in the CBRS band. They could be in a completely different band.
Precisely.
Right. So in a way,
precisely.
Yeah. So it's a challenging thing to deal with.
Dale, I think that's something that we definitely will, try to get some speakers, and if you have any suggestions to start addressing it. But I guess one of the problems that I'm grappling with thinking about is is this something we can know? Is this something we set in regulations? How do we address it is the problem. So I agree. The first issue is how widespread of a problem is it? And then the question is, how do we go about addressing it? Is it regulation? Is it receiver standards? I don't really know, because many times the intermod is a passive intermod happening with a third device that you cannot put a standard to.
Yes.
So it's a very, very difficult problem, and definitely something that we do plan to spend some time looking at going forward.
I've not personally spent enough. I've not got through the process of understanding the problem well enough to figure out what we could do about it. There's so much to do before I get to that stage. But anyway, I hope I've made my point here that this is a serious. I believe it's a serious issue that we need to address, at least, or be able to dismiss it confidently.
I think the issue is actually most serious for passive receivers because they are picking up such faint signals. So an intermod product that might not be a problem for an active receiver might very well end up being a huge problem for a passive receiver. And it's definitely a problem, I think.
Yeah, I would only say that there's some, critical medical applications and things out like that out there.
Yep.
That that could be disrupted by Intermod and hard to trace.
Yep.
Hey, folks, thanks, Dale, for raising this point. And I think at this point, Monisha and Andy, thanks a lot for a great report and all your great work. And we should probably move on to our last working group, the Emerging Technologies Working Group, which is Henning and Brian.
Thank you. Brian has a scheduling conflict, so I will be trying to do the summary of our work group. Our work group is a bit different in web development. One often hears the term full stack developer. I think we are a full stack working group. And we particularly, given kind of our very wide remit, a range of questions that we were charged to address, particularly appreciate our FCC liaisons who have been helping us and will continue to help us to focus on key questions because there's so much more than we can reasonably do given the wide set of questions they have. Next slide, please. We have a very active set of participants who have generally been very engaged in our discussion, asking questions, pressing our subject matter experts on material, and we look forward to delegating some of the responsibility for individual topics as well to our members listed here. Next, please. So, as I said, we are covering anything and everything in terms of traditional layers, from sensing at the physical layer, all the way up to applications and blockchain and security and so on. So both horizontally and vertically, if you like, probably the widest remit of all the working group, which is both interesting but also challenging simply because we have to figure out how we're going to organize this in a useful way, given that most of the subject matter experts by their nature are advocates of a particular technology, but we don't want to be essentially just be a stenographer of industry press releases in that. And so how do we balance presenting technology objectively, particularly as it impacts commission work, and also providing kind of maybe a caveats or limitations that might make some of these technologies have issues of maturity or maybe limitations in use and so on. How do we document that? So we are still in kind of a learning and organizing mode, given our somewhat unusual large scope. Next. So we're going through some of the charter questions that were posed to us. So the first broad question concerns really two issues that are only loosely linked, namely the overall IoT ecosystem, which has been rapidly evolving, I would say, in the last few years. There's been a lot more interest in IoT and unlicensed band, so kind of a LoRa, Sigfox type of systems, novel ways of designing incentives for deployment, which I'll get to, as well as just a much more widespread usage beyond kind of a classical industrial type of use cases. And almost every household probably has now or will have some kind of an IoT device in their household. Namely, for example, most meters, gas, electric meters, probably have a IoT flavor to them as opposed to having a meter reader show up for that. The other related topic is the semiconductor technology that enables these various services and devices in that, so all the way from front end to the digital baseband one. And so the discussion that we had in the emerging technologies group is how is industry responding to this increasing demand for connected devices that are not traditional devices that we think about, smartphones and PCs and tablets and so on, but are often very cheap devices, often embedded, often very specialized devices in that, but are not also are typically data devices. So they're not altimeters or medical treatment devices or radio telescopes. So they are data devices. So they're somewhat similar to cellular devices, but not really in the same sense, both in terms of economic price points that you can reasonably build them to, as well as behavior in that. So we have we're lining up a number of subject matter experts, the ones with a red check mark are the ones that we have heard from. So we've heard from Qualcomm. I'll talk about those in a bit in that, and we'll also be talking about two application developers as well. Next, please. So, and this is a continuation really, namely, what do we know about the type of hardware support for not so much the communication side, but the sensing side. I would argue that this notion that radio spectrum can be used for sensing is essentially we are looping back to very old uses, when radar being kind of an active sensing model where you're not really communicating bits, but you're sensing radio energy in that, radio astronomy and so on, that had received less attention and now is receiving a lot of interest in new applications, primarily location one. And that is also, I would say, reemergence. Ultra-wideband is not a new technology. It's been around for at least a decade. Indeed, there was a flurry of industrial interest. It subsided, I would say, for a number of years for cost and performance reasons, I'd say, and then because many of these problems could be more cheaply tackled by smartphones like Wi-Fi location and so on, but ultra-wideband is now becoming again a technology that is seeing new use for particular precision indoor location in that. So we heard from the FireArc consortium and from Google as on this already. Next, please. A unrelated topic to the type of ones we talked earlier, but certainly a pervasive one that has occupied the commission, I believe, for many years is beyond knowing what should happen during kind of normal days, sunny days, is literally what happens on stormy days, namely when the original, when your standard network connectivity is disrupted often by natural disasters in that. So we had a contribution by somebody from NRECA that explored these options, particularly from an electric utility perspective. We'll get to that a little bit, but new models that think about both redundancy, as in adding additional capacity that can withstand disruptions in parts, but also overlay networks that are separate from the standard network in that. Is there a difference between accessing the internet from network access in maybe additional disruptions that don't interfere with the local access, but make it impossible to access the internet because of gateway issues or middle mile issues, for example, the issue of power availability, and are there new techniques and technologies that are now available that go beyond kind of the classical notions of restoring connectivity after a disaster, which obviously the industry has had decades, if not a century of experience with, but it's largely been about putting wires back up type of thing, or cell towers back up, as opposed to some of the more technological opportunities that we now have in those areas that might allow more rapid and more cost-effective restoration. And that will be an ongoing topic as well. And before I forget that, I would this is one topic where one of the big challenges that our working group faces is to find the right subject matter experts, given this really wide sweep of topics. So if you, based on what you're hearing today outside the working group, say, I have just the right person for you, Brian and I would really be delighted to hear from you, even if you're not in the working group, but if you know of any person who can help us with any of these topics, don't hesitate to contact either of us, because we only have collectively a limited set of contacts and could certainly use more. Next, please. We have two additional kind of what you could perceive as being more futuristic technologies. We have not tackled quantum computing or quantum communications yet, but we have started to hear, because that's actually probably much more close by in timing, as in their startups certainly that are making significant noise, if you like, in the ecosystem that use blockchain in novel ways. So in particular, and we'll get to that in a minute in more detail, is as opposed to, there has been some discussion of using blockchains as in infrastructure, like as a kind of replacement for various directories, and maybe even for spectrum management as a way of trusted assignment of spectrum bands and clearing essentially a record of what spectrum assignments have been made and so on. But some of these newer startups actually pursue a different model, namely, how do you use smart contracts and coins and so on to foster deployment of wireless networks. So instead of a top-down model where you have a carrier getting commercial credit or using their internal financial resources to build a, let's say, 5G or 6G network, can you do this in a bottom-up way where individuals or small enterprises would be incentivized by a token to contribute resources to the network that is then integrated and resold to the actual users, again, in a blockchain model. So these are conceptually similar to kind of MVNO type of models, or some of the other models that carriers have used, where they use rural small carriers as part of their network, but they're organized very differently. So we've heard a company called, a startup called Althea, and we are looking forward to another company that has gotten a fair amount of press called Helium, operating right now in the LoRa system and for IoT, both of them. And we'll see how that turns out. I'll have more to say on that in a minute. Next, please. I mentioned outdoor and indoor location in that, namely that intersects both with Wi-Fi in particular. Wi-Fi, as most of us know, has been used for indoor location for quite a while, but it has been used more incidentally, as in through like signal strength measurements, for example, in that. But recent advances in Wi-Fi that have explicitly about time of flight type of metrics have expanded that into areas that we don't think of as Wi-Fi, that we, for example, car door locks and so on, and then ultra wideband as well as a separate technology that is now sufficiently cheap to integrate into smartphones, which just wasn't the case. So we heard from Intel and the FIRA Consortium on that as well. Next, please. We are still waiting to hear from two kind of unusual, if you want to call them that, participants in the general satellite space. SatPac will hear on Monday, and Chimera is on our list. And so we look forward to finding out more about small satellite deployment, but we haven't done anything on that yet. Next. We've also started to look at more what you might call traditional systems that have a decade-long history, but continue to be improved in both large and small ways. So, for example, we had a very interesting discussion with the ATSC, but Next Generation Television Standards, as to are there opportunities for hybrid broadcast cellular networks? And we look forward to hearing from some of the cable related entities in the future. Next, please. We also have a discussion on using optical and laser technologies or not. The notion of using laser for inter-building communication is at this point pretty old, as in it's been used for maybe at least a decade, probably longer. But we heard from a Project Tara, which was originally from one of the X-Lab from Google, a spin-off of the Loon project on how we can leverage, they were able to leverage some more advanced technologies to improve the distance and bandwidth performance of that. I'll have a little bit more in detail on that in a minute. Next. I'm going to dive a little bit deeper into some of those topics that we've just covered very briefly. And so we heard from two speakers. The FIRA Consortium is a version of ultra wideband. So that is a part of an IEEE standard, an 802.15 range, with the goal of providing very accurate, generally indoor but not restricted to that ranging. So you could imagine it being used in vehicles, for example, to do inter-vehicle ranging for smart vehicles, autonomous vehicles, for example. And they're trying to provide a full protocol stack on top, really, of the 802.15.4z technology, and then also provide certification. And so this would require additional RF technology in handsets or vehicles or industrial machinery, for example, in that, as opposed to the second model that I will get to. So we also heard from Google that they have plans to at least prototype UWB in their Pixel line of phones, Pixel 6, that has, I think, been announced since we heard from that. And one very interesting use case is to replace your proprietary vendor-specific, car manufacturer-specific car key with something that's on your smartphone in that, and uses distance sensing to provide secure ignition and lock or start for electric vehicles support in that avoids some of the issues that you might have heard about Bluetooth related key fobs that are where people are able to do man-in-the-middle type of attacks to pretend that you're near the vehicle when you're not in that. And the incentive for UWB is that it provides that type of physical security, as well as allows to overlay some data communication for additional security in that. But challenges remain to make that as a consumer product, as opposed to something that you could do in the lab on link budgets for distance, as well as how do you add yet one more antenna to an already overstuffed product in terms of antenna technology. Next, please. We heard from the president of ATSC in that where, as I suspect most of you have been following at least for a while, is that we've had a new advanced television, if you want to call it that, but really data broadcasting standard, ATS 3.0. So that really the first standard that can do data casting as a designed-in feature from a typical high power, high tower type of setups, as well as traditional linear TV, digital linear TV services in that. And it's a North American standard and is designed as a one-to-many in that. So discussion was, how do you possibly do a hybrid network that combines unicast data delivery using IP packets, internet packets, as ATSC supports, and then uses a variety of back channels, 4G, 5G, Wi-Fi, whatever DSL type of technologies as a back channel. And that idea has been bouncing around for quite a number of years, even before ATSC, but is now more technologically feasible in that, and with the incentive that you could have a multicast live event type of thing that goes to moves from a streaming mode to a broadcast mode for higher effective spectral efficiency, simply because you're reusing the bits not just for one streaming session, but others as well. We were informed about the launch of this in terms of devices, and that they anticipate a near 80% coverage by the end of this year in that, and that this also has some international interest in that. What is less clear is as to whether this theoretical capability of hybrid networks will find actual usage given the significant coordination difficulties. And we've seen versions of this in satellite communication where when they were hybrid systems, but they had a relatively short-lived existence. So some skepticism was offered. Next, please. As I mentioned, we then heard about broadly the topic of blockchains in networking, and we found it interesting, even if not all of our working group participants shared necessarily the full enthusiasm for this particular model, is that it's essentially a platform that allows the leveraging of network assets via the blockchain type technologies, so that payment and revenue sharing, both in terms of supply of network infrastructure as well as the demand, namely the consumption side, if you like, as a consumer, would be mediated not by a traditional carrier that sends checks to people who put antennas on their building, like happens today, or that send checks or credit card payments to a carrier at the end of a month, but are mediated by coins of a sort, Ethereum-style coins typically in that, and using microtransaction. And interesting use cases where reachability, rural broadband in particular, that our speaker emphasized that private LTE networks might be able to be extended to provide some public services on kind of a micro carrier model, so that if you're not using your whole capacity in a private LTE or 5G presumably network, you could offer that as a roaming mechanism to people via these micro payments in that. We will hear from other models where basically these type of blockchain models are used to incentivize deployment, where people before the network is deployed essentially get paid to deploy infrastructure by proving their location or bandwidth. Next, please. We then heard about location services. I mentioned UWB earlier, but 802.11 has been adding location services for about a number of years now, actually, using time measurements of what's called the fine time measurement protocol, which operates in both of the classical bands. It does not provide the UWB level of accuracy as such in its older models, where it was generally limited to multimeter type accuracy. So good enough to navigate an airport, not good enough for fine-grained positioning, say, for virtual reality type of applications. In that there's a new release in there that would provide significantly improved accuracy that particularly in the 60 gigahertz band, one of the newer Wi-Fi bands that's been proposed for indoor usage, might actually get you close to the UWB level of accuracy. And again, be of particular interest for industrial applications where very precise indoor positioning is relevant, as well as for gaming and virtual reality and similar applications where you want to have a good notion of where everybody is in space. And so this is in progress, but might actually, we didn't talk about it much, might also help with some of the long-running concerns about indoor location for 911 purposes in indoor building location, particularly in large spaces like airports and stadiums and so on, where it's really helpful to know where that person is who just called 911 so that you can dispatch to that precise location within a very large space that has a single address. Next, please. As I mentioned, we heard from NRECA, which are the rural electric cooperatives, the association of those, in that the speaker told us what they're doing to ensure recovery in that particular in terms of cyber threats. And one of the notions, which I think some of us were vaguely aware of, but she drove home, was that we think of electric grid as just kind of a one-way flow of electrons, so to say, to, at least logically, from generation to transmission or distribution, kind of a water-like model where things just, there's really no communication or anything up the chain. It is just dumb power going to the end user to a much more complex system because of the microgrids in that have distributed generation, that have much smarter components in that. And so that in particular, when we think about restoration, we often think only about restoration that as in you need a power system generally, at least after prolonged outages when you're out of battery power and you want to turn off your generators, that the power system was always crucial to restoring communication capability. But now we have the opposite dependency, namely that you can't really restore the power grid without reliable communication, simply because you need to control these elements such as distributed generation to safely add them back to the network without electrocuting, say, somebody who's working on the wires to put them back on the pole. You want to make sure that you only turn on the let's say solar systems or other distributed generation facility when it is safe to do so, but then allow this to happen before you have a fully operational grid in that, thus reducing the duration of power outages. Next, please. As I mentioned, we then heard from one of the Google X Labs scientists who has been working on this Project Tara, which allows a significantly higher capacity and at significant distances, point-to-point lengths at about 20 gigabits at 10 kilometers distances, in that it operates at a bandwidth of 190 terahertz, in that it is meant to be eye-safe, as in it is just not a high-powered laser, but it is perceived often to be most useful as a service that in itself has a backup, given that fog and in some cases also heavy rainfall may interfere with the service, so that if you're in an area that has fog or other pollutants like dust and so on that reduced visibility. Clearly, a free space optical isn't going to be 100 give you the kind of 5 nines reliability in that. So often it is supplemented with a lower bandwidth backup that provides some continuity during those periods of atmospheric non-transparency, generally. But it offers, compared to fiber links at similar capacity, a much quicker and cheaper installation as a transition model. So where you need fiber, you're going to get fiber in long term, say in a metro area where in principle you can get fiber, but it just takes a long time for permitting and construction and so on. And during that intermediate period, you can use a free space optical as a transition model. Next, please. Qualcomm told us about their 5G chipsets, which basically operate on a yearly release cycle that they do, probably in line with the typical release cycles of consumer smartphones in that, and how they intend to follow the releases that we heard about earlier from the 6G group in that, how these RF technologies enable more advanced use cases in that space. Next. We heard then about a very widely deployed technology, passive optical network, certainly one of the dominant technologies for new rural broadband deployments as part of the BEAD and RDOF and other subsidy programs where many, if not most, of the fiber networks all use passive optical. So we were provided with a very helpful history of how passive optical networks really more recently have transitioned from being their own technology, so to say their own ecosystem, to leveraging the very large data center market in optical interconnection in the local realm within a data center, that those now provide components that have pushed costs down and bandwidth up. So in particular, while earlier attempts to move from 10 gigabits GPON to 40 gigabits GPON didn't really work out, they weren't economically viable, we can now do these type of things with using technology derived or leveraged or borrowed from data centers in that. So one of the big questions is, while 10 and 40 gigabit type of GPON is likely to be sufficient for residential and small business use, it is unclear whether we can get to 100 gigabit per user type of peak rate without going to much more expensive coherent optical technology, which is obviously widely used for long distance links, but has not been used for passive optical networks. And so if you're interested in the state of PON in general, this is a good overview of what's been happening there. A relatively steady, but continuing speed up in that and cost curve transition, which is particularly relevant to rural broadband deployments, and also the replacement of some traditional DOCSIS type systems in some cases, as well as cellular access networks, naturally. Next, please. Okay. So that's a quick summary of some of the SMEs that we've heard from so far. We continue, we will have a lineup of new ones in that coming up. But what we're starting to think about in the group is, are there beyond, as you can tell, is about as diverse a set of topics as you can possibly imagine within the broad space of communication and sensing and systems that use frequencies of some sort. Are there some themes or patterns that are emerging that transcend the individual technology? And in particular, we are still struggling to define for these component technologies, how do they impact kind of a more consumer or FCC adjacent technologies such as 6G, next generation Wi-Fi, residential and access networks in both rural and urban areas, IoT beyond just in-home type stuff, positioning, again, including for emergency services, next generation broadcast, and restoration and backup in that. So we'll try to classify those. And we're looking forward to a discussion with our FCC liaisons on which aspects that one could look at for these would you have for FCC impact, because in some cases these technologies might enable additional competition, new entrants that add competitive players. In others, they're primarily useful because they add resiliency. And in others, they provide something which again is kind of a circling back to an older era where we had special purpose networks for each use case of communication or sensing, as opposed to kind of a universal network that supported everything from IoT, low bandwidth, to streaming multimedia, and maybe even sensing. What role do these special purpose networks play that may have very different business models and deployment models than kind of a traditional carrier-based model in that? Again, this is very blockchain and related models in that. And again, this is also one, given that we have such a wide remit in that and wide set of topics, if there are topics that you would like to know more about that impact your particular area, that where emerging technologies would help you ground your discussion or maybe provide some perspective, let us know about it, and we'd be happy to see if we'll let others know that this is a topic that might be of interest for you to join our Monday afternoon meetings, or where, as I said, if you have speakers who you would like to suggest to help us better understand those technologies. And in particular, it's not very useful except for the FCC staff that kindly attends our meeting. In the long run, we want to provide a report that provides more than just a summary of the slides, which is kind of what I've been doing today. Thank you. I think that's all I have. Questions or comments? I know we're close to the end of the time slot here, but.
Well, thanks a lot, Henning. That was amazingly comprehensive.
You're welcome. Oh, Michael, I see his hand up.
Yeah, since others are formulating their questions about the location accuracy of using some of the unlicensed bands and spectrum and so forth, that was very interesting. Do you know when the standards might be getting finalized and actually have some sort of a commercial service available?
Yeah, so I don't know the precise answer to that because that's probably mine. I know that for, let's say if we look at the unlicensed one, we really have two versions, namely the 802.11 one and the ultra-wideband one. And in both cases, I think in the 802.11, one of the challenges has been a bit of a chicken and egg problem, namely that you need both the access point, generally speaking, as a location anchor. You need to know where that thing is so that you know, because all you're measuring is distance to that. It doesn't really, it's not like GPS, so to say, directly. It is although that's in some sense similar, you do know those, but that's public data as to where your satellites are. But you need a known reference points that you can then triangulate between in that. And it's been challenging, from what I understand, to get consumer access points to support the model in that, and then to support it in that. But it sounded like for the 802.11 that was a year or two type of one where at least the standard, because it's in ballot right now, would be deployable. If I remember correctly, we asked about that as to how many changes this would require in chipsets. My recollection was, and others who might have been on the call might supplement my or correct my impression, that the changes were relatively minor, as in this would not require a re-engineering of a typical chipsets produced by a handful of vendors that provide most of these IEEE 802.11 type chipsets in that, but is a relatively minor addition. So this, to me, sounded at least that we're talking about a 2-year availability time frame, but the longer challenge of actually making it usable, say for emergency services, really only would work if the vast majority of access points, for example, supported it so that your cell phone could actually triangulate, and then you would have to position that as well. The UWB one to me sounded a little bit further out, simply because the cost of deployment of an additional one would be larger. And this was a surprise to me that, we think of location technology as being something that is motivated, besides maybe the emergency case, by commercial considerations like tracking people in stores and things like that might have been talked about for a number of years for some of the iButton and similar type of technologies that's been used, is that would be for car keys. Seems like that is and home keys. That would be the motivator that might actually drive that quicker than maybe one would have anticipated a year or two ago, simply because there's such a ready market for a secure access technology now in vehicles, as well as in for home IoT type of deployments, where you want to avoid having where location-based systems seem particularly advantageous. So that's my take. I don't know if anybody else who was part of the discussion has any additional input on that.
Thanks, Andy.
Okay.
Any other questions?